Welcome to the science for deep sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. Did you know you will spend about 6 years of your life dreaming? 6 full years. That's over 2,000 days, or nearly 230,000 hours, spent in a world that doesn't technically exist. Or does it? Every single night, your brain builds entire realities, places, people, and moments that can feel as real and tangible as waking life itself. We usually just write them off as random neurological noise, the brain's equivalent of TV static. But what if they're more than that? What if these nightly journeys, these phantom worlds we visit, are one of the biggest clues to understanding who we are, why we feel the way we do, and the very nature of consciousness itself? We're standing on the edge of a new understanding of dreams, one that goes way beyond simple interpretation and dives into the fundamental mechanics of the mind. To get there, we have to travel from the solid science of what happens when you close your eyes, to the radical new theories that are changing everything. This isn't just about sleep. This is about the architecture of your reality. The foundational science of dreams. Before we can even ask what dreams mean, we have to get a handle on what they are. At its core, a dream is just a sequence of images, feelings, and thoughts that your brain creates on its own while you sleep. But they're not just random firings. They are actively built experiences, pulled from the massive, sprawling library of your own life. Your brain acts like a surrealist filmmaker, grabbing fragments of your memories, echoes of your anxieties, and snippets of your hopes, then splicing them all together into a brand new, and often very weird, narrative. And while it's all happening, it feels completely real. You're not just watching a movie, you are in it. You feel that stomach-lurching drop when you fall, the panic of being chased, the pure joy of flying. This immersive quality is what makes dreams so powerful. Your senses are fully engaged. While most people dream in color, some studies suggest that around 12% of people report dreaming only in black and white. People who are blind from birth experience incredibly rich dreams, full of sound, touch, taste, and smell. Your mind doesn't need your eyes to see. It builds the world from the inside out. For a long time, the story of dreaming was really just the story of REM sleep. REM, or rapid eye movement, is a truly bizarre state. When it was discovered in the 1950s, scientists were stunned. It's a stage of sleep where your brain activity looks almost identical to when you're wide awake. Your eyes dart back and forth, your heart rate and breathing get irregular, and your brain is a lightning storm of electrical signals. And this is the crazy part, your body is almost completely paralyzed. A tiny part of your brainstem, called the pons, sends out signals that shut down your motor neurons. It's a genius safety mechanism that prevents you from physically acting out that frantic chase scene in your head, keeping you safe while your mind roams free. You cycle through different sleep stages all night, with each cycle lasting about 90 minutes. The first half of the night is dominated by deep, restorative sleep. But as you get closer to morning, your REM periods get longer and longer, with the last one stretching up to an hour. This is prime time for our most vivid, story-driven, and emotional dreams. If you've ever been yanked out of an incredible dream by your alarm clock, it's almost definitely because you were in the middle of REM. But the plot has thickened. For decades, we thought REM was the only place dreams happened. Waking people up from non-REM, or NREM sleep, usually got you nothing, or maybe a vague, fuzzy thought. But newer, more precise research has totally flipped that idea on its head. We now know people awakened from lighter NREM sleep report dreams more than 50% of the time. These dreams are different, though usually shorter, less emotional, and more like a single, looping image than a full-blown movie. In fact, recent studies using high-density EEG have made a stunning discovery. When a dream does pop up during NREM sleep, certain parts of the brain suddenly shift their activity to look more like they do when we're awake. It seems dreaming isn't tied to one sleep stage, but to a specific kind of brain activity. Scientists have even pinpointed a posterior cortical hot zone, an area at the back of the brain where a drop in slow-wave activity and a spike in high-frequency activity acts like a reliable signature of a dreaming brain, no matter the sleep stage. So why is your brain so busy? During REM sleep, some brain areas go into overdrive while others take a nap. The amygdala, your brain's emotion processing center, and the hippocampus, your memory hub, are highly active. This is a huge reason why REM dreams are so emotional and pull so heavily from our memories. Meanwhile, a really important region called the dorsolateral prefrontal cortex, the part responsible for logic and self-awareness, gets significantly dampened. This is why you can be having a dream where penguins can fly and your long-lost dog is giving you stock tips, and it all feels perfectly normal. The part of your brain that would usually say, "Hang on a second," is temporarily offline. You just accept the dream world on its own terms. This unique neural cocktail, high emotion, active memory, and low logic, is the perfect recipe for the strange and deeply personal theater of our dreams. Your brain isn't shutting down, it's entering a completely different mode of operation. The grand theories. Why do we dream? Okay, so our brain is busy building worlds every night. But the billion-dollar question that has stumped thinkers for centuries is still, why? Is dreaming just a meaningless byproduct of the brain's nightly cleanup, or does it serve a critical function? Over the years, a few major theories have emerged, each giving us a different piece of the puzzle. First up is the idea that dreams are crucial for asterisk memory consolidation. Think of your brain as a librarian who gets a flood of new information every single day. At night, that librarian has to sort through it all. This theory suggests that dreaming is what it feels like when your brain decides which memories to keep and file away in long-term storage, and which ones to toss. The bizarre stories in our dreams might just be the result of this filing process, as the brain connects new experiences to old ones in weird and unexpected ways. And there's solid evidence for this. A night of good sleep, especially REM sleep, consistently improves our performance on learning and memory tasks. A closely related, and maybe even more powerful, idea is that dreams act as a kind of asterisk overnight therapy. This theory proposes that one of sleep's main jobs is to strip the emotional charge away from our experiences. Here's the fascinating part. During REM sleep, your brain revisits emotional memories, but it does so in a brain that is almost completely free of noradrenaline, a key stress-related chemical. It's like re-watching a scary movie with the sound turned off. You can process the story without the intense fear. Over time, this helps integrate difficult experiences into our life story in a healthier way. This is why good REM sleep is so vital for mental health, and why disruptions to it are linked to things like PTSD, where the brain seems to get stuck on a traumatic memory without being able to file it away properly. But why are dreams so often negative or scary? This brings us to the asterisk threat simulation theory. Proposed by neuroscientist Antti Revensha, this theory looks at dreaming through an evolutionary lens. It argues that dreams are basically a virtual reality training ground for our brain to rehearse for dangerous situations. By simulating threats like being chased, falling, or fighting, our brain gets to practice its threat perception and avoidance skills in a totally safe environment. This would explain why so many of our dreams are anxiety-inducing. Our ancestors who had better threat simulation systems might have had a survival edge. While some studies show conflicting results, it's a powerful explanation for the often negative vibe of our dream lives. Finally, there's the theory of dreams as a hotbed for asterisk creative problem solving. The dream state, illogical, hyper-associative, and free from the rules of reality, is incredibly fertile ground for new ideas. While your logical prefrontal cortex is taking a break, your brain is free to make connections it would never make during the day. And history is full of amazing examples. The chemist Auguste Kekule famously dreamed of a snake biting its own tail and woke up realizing the structure of the benzene molecule. Elias Howe got the idea for the modern sewing machine needle from a dream about warriors with spears that had holes near the tips. Paul McCartney literally woke up with the entire melody for Yesterday in his head. These aren't just happy accidents, they show the brain's incredible power to find novel solutions when it's freed from the rigid logic of waking life. It's likely that no single theory has the whole story. Dreaming is probably more like a mental Swiss Army knife helping us remember, feel, prepare, and create, all at the same time. We've just scratched the surface of why we dream, and we're about to go a lot deeper. If you're finding this journey into the mind's architecture as fascinating as I do, hit that subscribe button. We've got so much more to uncover together. The deeper mystery, dreams and consciousness. So we've covered the what and explored the why of dreaming. But this is where the path takes a sharp turn into the deepest, most mind-bending mystery of all, the nature of consciousness itself. Some of the most radical ideas in neuroscience today suggest that dreaming isn't just something that happens in consciousness, it might be a fundamental clue to what consciousness actually is. Let's start with a wild idea from neuroscientists like Anil Seth. Your waking reality is also a kind of hallucination. Controlled hallucination, to be specific. The theory goes that your brain doesn't just passively absorb reality through your senses. Instead, it's constantly making its best guess about what's out there, based on all your past experiences. The signals from your eyes and ears? They aren't the full picture, they're just data that your brain uses to update and correct its guess, to keep the hallucination controlled and tethered to the real world. So think about what a dream is. It's what happens when this world-building process is cut loose from the outside world. The control is gone. Your brain is still doing the exact same thing, generating a reality, but now it's basing it entirely on its own internal library of memories and emotions. From this viewpoint, dreaming and waking aren't two totally different things. They're on a spectrum. Waking is a hallucination constrained by the world. Dreaming is a hallucination constrained only by the mind. This reframes dreaming not as some weird glitch, but as a purer, rawer form of the very mechanism that creates your reality every single moment. This leads to an even bigger idea. Dreaming might be a distinct, second state of consciousness. We tend to think of consciousness as a simple on-off switch, you're either awake or you're not. But modern neuroscience shows it's much richer than that. Dreaming, especially in REM sleep, isn't a lack of consciousness, it's a profound alteration of it. It's a state with its own unique rules, high emotion, warped time and space, and an uncritical acceptance of absolutely bizarre events. And within this alternate state, something truly extraordinary can happen: lucid dreaming. A lucid dream is any dream where you suddenly realize you're dreaming. It's that aha moment where, in the middle of some crazy scenario, part of your mind clicks on and recognizes the unreality of it all. For most of us, it's a rare and fleeting thing. But some people can not only recognize the dream state but actively control it, changing the scenery, summoning people, or giving themselves superpowers, all while sound asleep. Lucid dreaming isn't fantasy, it's a scientifically validated phenomenon. Researchers have brought lucid dreamers into sleep labs and watched as they signaled their lucidity from inside the dream using pre-arranged eye movements. And when they look at what's happening in the brain during a lucid dream, it's astonishing. Brain regions that are normally quiet during REM sleep, especially parts of the prefrontal cortex linked to self-awareness and logic, suddenly spark back to life. It's like the you that was offline suddenly reboots, creating a hybrid state of consciousness that's not quite waking and not quite dreaming, but something new altogether. Think about what that means. It suggests you can have a conscious, observing I that is separate from the dream world it's in. It's consciousness watching its own simulation. This tells us that the self isn't some fixed, solid thing, but a flexible process that can be turned on and off, or even exist in layers. In a lucid dream, you are both the creator of the world and a conscious citizen within it. This all connects to one of the toughest puzzles in neuroscience, the binding problem. How does your brain take all the separate bits of information, the color of a flower, the sound of a bee, the feeling of sun on your skin, and bind them into one single, unified experience? Well, the dreaming brain does this too, just with different rules. It seamlessly binds impossible things: a high school classroom that's also a submarine, a person who is both your mother and a movie star. By studying how the brain pulls off this surreal binding in dreams, scientists hope to figure out how it creates our normal reality. The mystery of dreams, then, isn't separate from the mystery of consciousness. They're one and the same. We started with a simple fact: you spend years of your life inside worlds your own brain creates. We journeyed through the science, discovering the nightly ballet of REM sleep. We explored the big theories that frame dreams as our personal therapist, our memory archivist, our threat simulator, and our creative muse. But then we pushed further, to the very edge of what we know. We saw how our waking world might just be a controlled hallucination, and dreams a rawer version of that same reality-building machine. We saw how lucid dreaming cracks open the definition of consciousness, revealing a hybrid state where self-awareness can bloom in the middle of a dream. What we're left with isn't a neat answer, but a much more exhilarating mystery. Dreams aren't just neurological static. They are a fundamental part of who we are, a sophisticated process that helps us learn, heal, and create. More than that, they are a nightly reminder that the reality we take for granted is a masterful construction of the 3-pound universe inside our skulls. The science of dreaming is no longer just about interpreting symbols, it's about trying to reverse engineer the source code of consciousness itself. The biggest questions are still out there. If our brains can build such convincing realities all on their own, what does that really say about the one we're in right now? And what other hidden powers of the mind are we just beginning to discover in the dark of the night? Every dream is another clue in this grand mystery. So what's the strangest, most meaningful dream you've ever had?
One that stuck with you for years, or one that taught you something you couldn't have learned while awake? Share your story in the comments below. Let's keep exploring this together. Part 2: What scientists mean by consciousness. Before anyone can ask whether consciousness might have something to do with quantum physics, or whether dreams are revealing something deeper than ordinary sleep, we have to pause beside a quieter question, a more basic one. What is consciousness in the first place? It sounds like one of those huge, almost impossible words. The kind of word that belongs in lecture halls, philosophy books, and long debates that never quite end. But in another sense, it is the most familiar thing in your life. You have never held it in your hand. You have never seen it sitting on a table. And yet you have never been more intimate with anything. Consciousness is the feeling of being here at all. It is the redness of red, the warmth of a cup in your hands, the sound of rain at night, the private ache of a memory, the strange, immediate fact that your life is not just happening, but being experienced from the inside. A computer can process information. A camera can record light. A microphone can capture sound. But none of those things, as far as we know, feel anything. They do not taste sweetness. They do not feel embarrassment. They do not lie awake wondering who they are. Consciousness seems to be the difference between information simply existing, and that information becoming part of a lived inner world. And that is where the mystery begins. Because science is very good at measuring things that can be observed from the outside: heart rate, brain waves, hormones, electrical activity, oxygen use, sleep stages, reaction times. But consciousness is unusual. It is deeply real, yet deeply private. No one can crawl inside your awareness and experience your experience exactly the way you do. They can ask you questions. They can watch your brain. They can study your behavior. But the actual feeling of being you remains locked inside the quiet interior of your own mind. That makes consciousness one of the strangest subjects in all of science. It is the one thing every sane person knows directly, yet the one thing no one can fully point to from the outside. So when scientists talk about consciousness, they are usually not trying to solve every mystery at once. They begin more modestly. They ask, what are the signs that a being is conscious? What are the conditions that seem to support it? How does it change? When does it disappear? When does it return? Which parts of the brain seem necessary? Which are not? They are not starting with a final answer. They are starting with clues. And one of the most helpful clues is this. In modern science, consciousness usually means subjective experience. In plain English, it means there is something it is like to be that being in that moment. There is something it is like to be awake in a dark room. Something it is like to hear your name. Something it is like to dream that you are falling. Something it is like to feel afraid, relieved, curious, calm. If there is an inner point of view, some private field of experience, then consciousness is present in some form. That definition is simple, but it immediately helps us clear up a lot of confusion. For one thing, consciousness is not exactly the same as intelligence. A calculator can outperform you at arithmetic without being conscious. A chess engine can defeat grandmasters without feeling proud of itself. Intelligence is about solving problems, adapting, learning patterns, maybe planning ahead. Consciousness is about having an inner life while any of that is happening. It is also not exactly the same as language. You can have an experience before you put words to it. A baby may not be able to describe pain, but that does not mean pain is absent. A dog may not write poetry about joy, but many people would say it is difficult to watch a dog greet its owner and believe there is no inner experience there at all. Scientists debate the edges of this, especially in animals, but most would agree that language and consciousness are not identical. And consciousness is not quite the same thing as memory either. You can be fully conscious during an event and later forget it. That is part of what happens under certain forms of anesthesia, during seizures, or after heavy intoxication. Consciousness may have been present in the moment, while memory failed to preserve it. So being able to remember an experience later is not the same as having had the experience in the first place. Even being awake and being conscious are not perfectly identical. Usually they travel together. Most of the time, when you are awake, you are conscious, and when you are deeply asleep, consciousness fades or changes dramatically. But the boundary is not that tidy. Someone can be awake in the physical sense, with their eyes open, but mentally absent, confused, or moving through automatic routines with very little reflective awareness. On the other side, a sleeping person can be immersed in a vivid dream world that is unquestionably a form of conscious experience, even though the body lies still in bed. This is one reason sleep is so important to the science of consciousness. Sleep reveals that consciousness is not an on and off switch. It is more like a landscape with different weather. There is ordinary wakefulness, where the outer world dominates and the senses keep updating the brain. There is daydreaming, where attention loosens and inner imagery begins to compete with what is happening around you. There is dreaming, where the outside world fades and the mind generates a world from within. There is deep, dreamless sleep, which many people later describe as blankness, though even that blankness is more mysterious than it first appears. Then there is anesthesia, coma, vegetative states, minimally conscious states, seizures, lucid dreams, meditation, intoxication, delirium. The closer scientists looked, the less consciousness behaved like a simple lamp that is either lit or dark. Instead, it began to look layered. This matters because for a long time people casually treated consciousness as if it simply meant being awake. But wakefulness is only part of the story. A person may be awake but not self-aware. A person may be asleep but vividly conscious inside a dream. A person under anesthesia may later report what seems like no experience at all, almost as if time had been cut out and stitched back together. From the outside, all of these states may look similar in some ways. From the inside, they are profoundly different. And that brings us to another distinction that scientists often make, one between consciousness and attention. Attention is like a spotlight. It selects one thing from many: the ticking clock, the sentence you are reading, the itch on your arm, the voice in a crowded room. Your brain is constantly flooded with more information than it can fully process at once, so attention helps prioritize what matters right now. But the spotlight is not the whole stage. Consciousness seems wider than attention. You may be focusing on one sentence while still faintly aware of the room around you, the feeling of your chair, a distant sound outside, and the mood you brought into this evening. Some things sit at the center of consciousness, brightly lit. Others remain dim, but not absent. In that sense, attention may shape consciousness, but it does not fully define it. This becomes even more interesting when attention and consciousness seem to part ways. Sometimes you drive a familiar route and suddenly realize you remember almost none of the last few minutes. Your brain was clearly taking in information. You stopped at lights, stayed in your lane, adjusted speed. But your reflective awareness was thin. Or think of when someone says your name in a noisy room and it cuts through instantly, even though you were not consciously attending to the surrounding voices. The brain was monitoring more than the spotlight suggested. These experiences hint that a great deal of processing happens outside consciousness. The brain is doing far more than the conscious self can ever narrate, and yet consciousness still feels central. Why? One reason is that conscious contents tend to be the information that becomes available to the wider mind. When something enters consciousness, it can often be remembered, spoken about, compared, judged, connected to goals, folded into the story of me. Some scientists think this broad availability is one of consciousness's main functions. In simple terms, consciousness may be the brain's way of putting certain information on the main stage so many different mental systems can use it at once. This idea appears in one of the best-known scientific models, often called global workspace theory. The details can become technical, but the core picture is surprisingly intuitive. Imagine a dark theater. Most mental processing happens backstage, quietly and automatically. But every now and then, one piece of information steps into the light on the main stage. Once it is illuminated, many systems can access it. Memory, decision-making, language, emotion, planning. In this view, consciousness is not every process in the theater. It is what happens when something gets broadcast widely enough to become part of the shared show. Another influential idea takes a different angle. Instead of asking whether information is broadcast, it asks how deeply it is unified. Why does your experience feel like one experience, instead of 1,000 separate bits? Right now, color, sound, memory, bodily sensation, emotion, and thought are all somehow woven together into one continuous field. You do not experience your life as disconnected files. You experience it as a whole. Some scientists think this integration, this binding together, is a key feature of consciousness. And that word, binding, takes us very close to the heart of the mystery. Think about what is happening as you sit here. Perhaps you hear a fan or distant traffic. Perhaps your eyes follow these words. Perhaps your body is aware of weight, temperature, breath. Perhaps there is a faint emotional tone in the background, peaceful, tired, curious, restless, or some mixture of all four. These are different streams of information, handled by different parts of the brain. And yet your experience is one experience. One room. One moment. One self, at least most of the time. How does the brain achieve that unity? No one knows completely. And that is one reason consciousness still fascinates scientists, philosophers, and anyone who has ever lain awake at night wondering what a mind really is. But before we go further into theory, it helps to return to ordinary life, because the most useful clues are often hiding there. When you wake from a vivid dream, there is sometimes a strange lingering feeling. For a few seconds, the dream world still seems half real. Then the waking world takes over. The bedroom becomes stable. Memory rearranges itself. Logic returns. You realize that the dream was internally generated. Yet while you were in it, it felt real enough to believe. That fact alone tells us something profound. Consciousness is not simply a mirror held up to external reality. It is a world-making process. In waking life, that process is strongly guided by incoming sensory data. Light enters the eyes. Sound reaches the ears. Touch, smell, temperature, balance, and the internal signals of the body all keep the brain anchored to the external world. But the brain is not passively receiving all that like a blank screen. It is actively interpreting, predicting, filling in gaps, deciding what matters, suppressing noise, stitching fragments into a stable scene. In dreams, much of that outside guidance drops away. But the world-making process continues. That is why the science of dreams and the science of consciousness are so deeply connected. A dream is not just a weird side effect of sleep. It is proof that the mind can generate a whole lived reality from the inside. It may be unstable, emotional, illogical, and strange, but it is still experienced as a world. And this raises a big question. If consciousness can exist in such different modes, then what is essential to it? Is it sensory input? Not entirely, because dreams occur without much outside input. Is it logic? No, because dreams remain conscious even when logic becomes weak. Is it self-awareness? Not always, because you can be conscious without clearly recognizing yourself as a self in the reflective sense. Is it memory? Again, not completely. Some moments are conscious but barely retained. The more scientists study consciousness, the more it resists reduction to any single ingredient. Instead, it begins to look like a family of related capacities. Awareness of something, a unified field of experience, a point of view, the ability for certain information to become globally available in the mind, a sense, however minimal, that experience is happening to someone, or from somewhere. That last part is especially important, because consciousness is not only about the world, it is also about selfhood. By selfhood, scientists do not necessarily mean your full autobiography, your name, your job, your opinions, your favorite songs, your regrets from 10 years ago, or the story you tell yourself about your future. Those are parts of the narrative self. Useful parts. Real parts. But deeper than that is something simpler and older. There is the felt sense that experiences are happening here. The sound is heard here. The fear is felt here. The dream is lived here. Even before you say, I, there is a center of experience from which the world appears. Some researchers call this the minimal self. Not the social self. Not the remembered self. Not the polished self. Just the immediate sense of being the subject of experience. And even that is not as fixed as it feels. People can lose aspects of body ownership in certain neurological conditions. They can feel detached from themselves. They can feel as if a limb does not belong to them, or as if they are observing themselves from a distance, or as if the boundaries between self and world have blurred. Meditation practitioners sometimes report a quieter form of this, where the usual chatter of me softens and experience feels more open. Certain dreams do something similar. In them, the self can shift, fragment, or become strangely fluid. You are still conscious, but the usual frame of identity is altered. This suggests that the self is not a single solid object buried inside the brain. It may be more like a process the brain continually builds, updates, and stabilizes. And that can sound unsettling at first, but it is also freeing. It means the everyday self, the one carrying stress, roles, expectations, and inner commentary, may not be the deepest layer of consciousness. Beneath all that storytelling there may be something simpler, more immediate, and quieter. Just awareness itself. If this kind of calm exploration is helping you unwind, this is a lovely point to like the video, subscribe, or leave a comment about where you're listening from tonight. It always makes the channel feel a little more human, and a little less like voices floating in the dark. Now, there is another important distinction scientists often make, and it may be the most humbling of all. They separate what consciousness does from why it feels like anything at all. This is sometimes called the hard problem of consciousness. The easy problems, easy only by comparison, are questions like these. How does the brain integrate information? How does attention work? Why does wakefulness differ from dreaming? Which circuits are involved when awareness fades under anesthesia and returns afterward? How does the brain distinguish self from world? Those are hard questions in the ordinary sense. They are difficult, but they are the kinds of questions science knows how to approach, measure, compare, test, refine. But then there is the deeper puzzle. Why should any of this brain activity feel like something from the inside? Why should electrical signals and chemistry produce the taste of coffee, the sting of grief, the softness of moonlight through a curtain, the embarrassment of a social mistake, the private atmosphere of a dream? Why is there an inner movie at all? You can describe a brain from the outside in exquisite detail. You can map neurons, record firing patterns, identify networks, watch blood flow change as a person sees a face or hears music. But no matter how complete the map becomes, one question remains hanging in the air like mist. Why should any of that have a first-person point of view? That is where science becomes careful. Honest scientists do not pretend the mystery is solved when it is not. They can tell us more and more about the conditions under which consciousness appears. They can compare wakefulness, dreams, anesthesia, coma, and altered states. They can identify patterns that travel with consciousness. They can rule out simple mistakes. They can build better models. But the final leap from brain activity to felt experience remains one of the deepest open questions we have. And perhaps that is why consciousness has always felt slightly luminous to people, slightly beyond the edges of easy explanation. It is not magic in the cheap sense, but it is mysterious in the truest sense. It is the one phenomenon through which every other phenomenon is known. Without consciousness, there would still be stars, oceans, atoms, gravity, and light. But there would be no wonder, no beauty, no fear, no story, no dream of understanding. Consciousness is the condition under which a universe becomes experience. So when scientists say the word consciousness, they usually mean something both simpler and stranger than people expect. They do not mean a ghost in the machine. They do not necessarily mean a soul, though some people may interpret it that way. And they do not mean a fully solved mechanism. They mean the presence of experience. The fact that some systems, somehow, do not merely process the world but live through it. They mean the difference between a sleeping body with no reportable awareness and a dreaming mind wandering through an inner landscape. They mean the difference between seeing and merely detecting, between reacting and feeling, between information existing and life being present from the inside. And once you see consciousness this way, as a shifting field rather than a simple switch, the old categories begin to soften. Awake and asleep are not total opposites. Selfhood is not perfectly fixed. Attention is important but incomplete. Logic is useful but not essential. Memory matters but is not the whole thing. The brain is active in many states, but only some patterns seem to produce that elusive, unified, lived quality we call awareness. That is the territory we are entering. Dreams matter because they show consciousness untethered from ordinary reality. Sleep matters because it reveals how awareness can fade, transform, and return. The brain matters because all current evidence points to it as the platform through which conscious experience is organized. And the mystery matters because, even now, after all our technology and all our theories, we still do not fully know why a brain should feel like a mind. Maybe that is the gentlest way to end this part. Consciousness is familiar enough to be taken for granted, yet strange enough to humble science. It is the light by which you know your life, and the one light whose source we still cannot fully see. We know some of its conditions. We know some of its rhythms. We know it can narrow, widen, fracture, vanish, and bloom again. We know it can build worlds out of sensory input, and sometimes out of almost nothing but memory, emotion, and imagination. And as the room grows quieter, and the ordinary world loosens its hold, that mystery becomes easier to feel. Because every night, without fail, consciousness changes shape. It slips away from the solid edges of waking life. It leaves behind the stable rules of the day. And then, in the dark, it begins building again. A voice, a place, a sky that never existed, a face from childhood, a door that opens into another impossible room. And that is where our journey is heading next. Not just towards sleep, but toward the strange physics of a mind that can keep experiencing, even while the world outside goes still. Part 3: What quantum physics really means. There is a certain kind of mystery that feels ancient. The kind that belongs to stars, to darkness, to dreams, to the quiet sense that reality may be stranger than it appears. And then there is another kind of mystery, a more modern one, born in laboratories and equations, discovered not by staring into the night sky, but by looking very, very closely at the smallest things in the universe. That is where quantum physics begins. And if the phrase itself sounds intimidating, that is completely understandable. It has become one of those terms that people use in documentaries, in books, in spiritual conversations, and sometimes in ways that make it sound almost magical. It can feel like a word wrapped in fog, mysterious, impressive, a little slippery, as if it points to something deep, but never quite tells you what that something is. So for this part, we are going to do something simpler, and much calmer. We are not going to rush toward exotic conclusions. We are not going to pretend that every strange idea is proven. We are not going to use quantum physics as a poetic shortcut for anything is possible. Instead, we are going to sit with the subject slowly, almost the way you might sit beside a quiet stream at night, and try to understand what scientists actually mean when they talk about the quantum world. Because before anyone can ask whether quantum physics has anything to do with the brain, with dreams, or with consciousness, we first need to understand what quantum physics really is. At its heart, quantum physics is the science of very small things. That may sound almost too simple, but it is the right place to start. The world you see around you feels solid, continuous, stable. A chair is a chair. A table is a table. A wall stays where it is. A glass falls in a predictable way. The moon hangs above the earth without flickering in and out of possibility. Everyday life has a certain reassuring heaviness to it. Things appear to behave according to rules that are reliable enough for us to trust without much effort. If you drop a spoon, you do not expect it to become a cloud of maybe. If you roll a ball across the floor, you do not imagine it taking several paths at once. If you look at the lamp in your room, you do not suspect that its deepest nature is governed by probabilities rather than certainties. And yet, when scientists began probing matter at extremely small scales, they discovered that the universe underneath the visible world does not behave quite the way common sense would expect. To understand why that was so shocking, it helps to step back for a moment and remember how people once imagined matter itself. For a long time, scientists pictured atoms as tiny, solid building blocks, little particles of matter that made up everything else. A useful image, neat and mechanical. And in some ways, that picture worked. It helped explain chemistry, structure, and the basic idea that ordinary objects are made of smaller parts. But as experiments became more precise, that simple picture began to crack. Atoms were not indivisible after all. They contained smaller pieces. Electrons, protons, neutrons. Then even some of those turned out to have inner structure of their own. The deeper scientists looked, the less reality resembled a set of tiny billiard balls clicking predictably through space. Instead, it began to resemble something softer, stranger, and harder to picture. At the quantum level, the universe does not offer us the kind of certainty we are used to. It offers tendencies, patterns, probabilities, and events that only become definite in particular ways. This does not mean the quantum world is chaos. That is an important point. It is not random nonsense. It obeys laws, and those laws are so precise that quantum physics has become one of the most successful scientific frameworks ever developed. The modern world depends on it more than most people realize. Semiconductors, lasers, MRI machines, much of modern electronics, and many of the technologies woven quietly into daily life would not exist without quantum theory. So this is not fringe science. It is not speculation floating without evidence. It is real, tested, and astonishingly effective. But it is effective in a way that often feels emotionally unfamiliar. Classical physics, the physics of ordinary objects, lets us imagine the world almost like a great machine. If we know where something is, how fast it is moving, and what forces act upon it, then in principle we can predict what happens next. That picture is not perfect in every situation, but it fits everyday experience well enough to feel intuitive. Quantum physics breaks that feeling. It tells us that the smallest parts of nature do not always have sharply defined properties in the way we expect before we measure them. It tells us that light can behave like a wave and a particle, that electrons do not orbit the nucleus like tiny planets in neat little tracks, even though children's textbooks often draw them that way, that what we can say about a particle often comes in the language of probability, not certainty. And this shift matters. It matters because it changes not only what we know, but how we imagine knowing itself. A helpful way to begin is with light. Light seems simple because we live with it every day. Sunlight through curtains, a lamp beside a bed, the blue glow of a phone screen late at night. But light has been one of the great teachers of modern physics, and one of the first clues that reality was stranger than expected. For a long time, light was understood mainly as a wave. That made sense. Waves can spread out, interfere, bend, and create patterns. And light does all of those things. But then experiments showed that light also behaved as if it came in tiny packets, later called photons. In some situations it looked wave-like. In others it looked particle-like. It did not stay obediently inside one category. This was deeply unsettling at first, because the human mind likes stable labels. We want to ask, well, which is it really? A wave or a particle? And quantum physics answers, in its quiet and infuriating way, that the question may be too small for reality. Light is not simply one familiar thing pretending to be another. It belongs to a deeper level of nature where the categories we built from ordinary life stop fitting neatly. Sometimes the mathematics of waves describes it best. Sometimes the mathematics of particles does. Both are real descriptions of something that resists being reduced to our everyday language. And once that door opened, it did not close again. Electrons behaved strangely too. They produced interference patterns, as waves do, but were also detected as localized impacts, as particles are. Matter itself seemed to have a kind of double identity. The old world of hard, tiny objects began dissolving into something more elusive. If that sounds abstract, there is one famous experiment that captures the weirdness more clearly than almost anything else. It is often called the double-slit experiment. The setup is simple enough to describe in a sleepy room at midnight. Imagine a barrier with two narrow openings in it, and a screen behind it. If you send ordinary little pellets through the slits, you would expect them to go through one opening or the other and form two piles on the screen. That is exactly what common sense predicts. But if you shine light through the slits, you do not simply get two bright bands. You get an interference pattern, a series of alternating bright and dark stripes, the hallmark of waves overlapping with each other. So far, so strange but manageable. Waves do that. Then physicists tried sending particles, like electrons, one at a time. And somehow, even one at a time, the pattern that slowly built up still looked like an interference pattern, as if each electron were not merely acting like a tiny bead passing through one slit, but like something spread out, something capable of behaving like a wave and interfering with itself. That single image changed how people thought about matter. Because the world at small scales did not seem to be waiting politely to reveal a simple underlying picture. It was telling us, rather firmly, that our ordinary intuitions were not built for this terrain. One common way of describing the quantum world is to say that particles are also described by wave functions. You do not have to memorize that term, but it helps to understand the idea behind it. A wave function is not exactly a visible wave like the ripples on water. It is more like a mathematical description of possible outcomes. It tells us where a particle is likely to be found, what states are likely, how probability is distributed before a measurement is made. That word, likely, is doing a lot of work here. Because one of the most important shifts in quantum physics is the move from certainty to probability. In ordinary life, if you know enough about a thrown baseball, you can estimate where it will land. In quantum physics, you do not usually say, the electron is exactly here and heading exactly there. You say something more like, there is a certain probability of finding it here, and another probability of finding it there. This is not merely because our instruments are clumsy. At least according to the standard interpretation, probability is not just a temporary sign of human ignorance. It is built into the structure of the theory itself. Nature, at this level, does not always hand us exact pre-written certainties. And that leads us naturally to one of the most famous principles in all of physics, the uncertainty principle. People often hear that name and imagine it means scientists are confused, or that quantum theory is vague. But that is not what it means at all. The uncertainty principle, closely associated with Werner Heisenberg, says that certain pairs of properties cannot both be known with arbitrary precision at the same time. The classic example is position and momentum. The more precisely you know where a particle is, the less precisely you can know its momentum. And the more precisely you know its momentum, the less precisely you can know its exact position. Again, this is not just a flaw in our measuring devices, as if we simply need better microscopes. It seems to reflect something fundamental about the world. At the smallest scales, nature is not offering us a perfect little diagram with every value pinned down at once. For the human mind, this is difficult because it feels like an offense against common sense. We imagine the universe as fully definite, even if hidden from us. Quantum physics suggests something subtler. Some aspects of reality may only become sharply defined in the context of specific measurements, while other possibilities remain open until then. This brings us to the word that appears in almost every popular discussion of quantum theory, and often in ways that are more dramatic than helpful: superposition. The simplest way to think about superposition is this. In the quantum formalism, a system can exist in a combination of possible states before measurement rather than occupying one familiar, definite state in the classical sense. That sentence is accurate, but perhaps a little dry. So let us slow it down. Imagine a coin lying flat on a table. In everyday life, it is either heads or tails, even if you have not looked yet. Your ignorance does not change the fact. One side is facing up. But in quantum theory, a system may be described in a way that is not just, we do not know yet. It may truly be in a superposition of possible outcomes, a structured combination of states that only yields one definite result when measured. This is why people sometimes say, a bit too casually, that a particle is in two places at once. That phrase is not completely wrong, but it can be misleading. It makes the quantum world sound like a tiny circus trick. A better way to say it is that before measurement, the system is described by a spread of possibilities that does not map neatly onto classical either or pictures. And yes, this is weird. It is weird even to physicists. Some of the greatest minds in science spent years arguing about what quantum theory really meant beneath the equations. Einstein famously disliked the idea that chance might sit so deeply inside nature. He did not deny that quantum mechanics worked. He knew the equations were powerful. What troubled him was the interpretation. He resisted the thought that reality might be fundamentally indeterminate in the way the theory suggested. This is where his famous line comes from, that God does not play dice. Others, like Niels Bohr, took a different view. They argued that quantum theory was not broken. It was simply telling us that reality at that scale does not conform to our classical expectations, and that our job was to accept what the experiments and equations showed, even if our intuitions protested. This debate matters because it shows something human and beautiful about science. Even the people who built the deepest theories were still struggling to emotionally digest what the universe was saying back to them. If you are finding the quantum world a little dreamlike, a little slippery, that is not because you are failing to understand it. It is because reality itself, at that depth, seems to stop behaving like the sturdy furniture of daily life. And yet there is another layer of strange still waiting for us. Entanglement. Entanglement is one of those words that sounds poetic even before you know what it means. And in a sense, it is poetic. But it is also experimentally real. When two quantum systems become entangled, their properties become linked in such a way that they can no longer be fully described independently. Measure one, and the other is correlated with it, even if the two are far apart. The details are subtle, and it is easy to oversimplify, but the important feeling to keep is this: in the quantum world, separateness is sometimes less absolute than our ordinary intuition suggests. Einstein found this deeply unsettling too. He called it spooky action at a distance. The phrase has survived because it captures the emotional mood of the discovery. Not nonsense. Not magic. Just deeply strange. Now, to be careful, entanglement does not mean thoughts can instantly control the cosmos, or that anything anyone wants can happen by quantum manifestation, as some people claim. The real science is much more disciplined than that. Entanglement produces precise statistical correlations under specific physical conditions. It is not a blank check for fantasy. But it does tell us that the quantum world is more interconnected, and in some ways more relational, than the world of ordinary objects seems to be. By this point, you may be wondering something simple and reasonable. If the quantum world is so strange, why does the world around us feel so normal? Why do tables not blur into possibilities? Why do cats not seem half here and half elsewhere? Why does the moon stay put? The answer seems to be that the larger world we live in is made of unimaginably many particles interacting constantly with their environment. Those interactions cause delicate quantum effects to wash out very quickly at everyday scales. A process called decoherence helps explain why superpositions that are meaningful in tiny, isolated systems do not usually survive in the messy, warm, noisy conditions of daily life. This is one reason quantum mechanics feels so distant from ordinary experience. It governs the foundation, but the surface world we live in is more stable, more classical, more settled. The weirdness is real, but it usually hides beneath the threshold of direct human perception. Still, the weirdness remains part of the foundation, and that fact can quietly change the way reality feels. Because once you understand even a little of quantum physics, the world no longer seems made of simple solid things sitting passively in empty space. It begins to look more like a layered mystery, a reality where certainty softens into probability, where particles are not quite particles in the everyday sense, where observation and measurement matter, where the smallest scales are described not by the logic of common sense, but by the mathematics of possibility. If this calm dive into difficult ideas is helping you settle in, This is a gentle moment to like the video, subscribe, or leave a comment about which part of quantum physics feels strangest to you. It is always interesting to see which ideas stay with people after the lights are low and the room is quiet. There is also a very important caution we should keep in view. Because quantum physics is strange, people are often tempted to use it as a kind of universal permission slip. They say things like, quantum means consciousness creates reality, or quantum means anything can happen, or quantum proves the universe is pure thought. But science does not move that way. A mysterious theory does not automatically validate every mysterious claim. Strange does not mean limitless. Weird does not mean magical. The most honest thing we can say is this: quantum physics gives us an extraordinarily accurate description of matter and energy at very small scales. It shows that nature is more subtle and less classically definite than earlier models suggested. It tells us that probability, uncertainty, superposition, and entanglement are part of the real behavior of the world under certain conditions. But whether those facts have anything meaningful to do with the brain or consciousness is a further question. A separate question. A question that must be handled carefully. And that is exactly why we needed this part. Because to explore that later question responsibly, we first needed to clear away the fog. We needed to see quantum physics not as a mystical slogan, but as a real scientific framework with specific meanings and real limits. So let us gather the thread gently before we move on. Quantum physics begins when the universe gets very small. At that scale, matter and light stop behaving like the neat, solid objects of common sense. Light behaves in both wave-like and particle-like ways. Matter does too. Instead of exact certainties, we get probabilities. Instead of fully fixed values for everything at once, we encounter uncertainty. Instead of one obvious state, a system may exist in superposition. Instead of full independence, systems may become entangled. None of this means the world is irrational. It means reality is deeper than our habits of thought. And perhaps that is part of why the quantum world has fascinated so many people for so long. Not because it gives easy answers, but because it reminds us that the universe is not obligated to feel intuitive. Nature is under no duty to match the furniture of the human mind. In a way, that makes quantum physics feel a little like dreaming. Not because dreams obey quantum equations in any simple sense, but because both reveal a gap between the world as it feels and the world as it may actually be. In dreams, the mind shows us how easily reality can be constructed, bent, or rewritten from within. In quantum physics, nature shows us that even the material foundation of the world is stranger than the waking mind once assumed. By day, the world seems firm, solid, and obvious. By night, in dreams, it becomes unstable and fluid. And beneath both, at the smallest scale we have yet discovered, reality itself turns out to be quieter, softer, and far less straightforward than it first appears. That is where we will leave it for now. We have not tried to solve the whole mystery tonight, only to make the ground beneath the mystery a little clearer. To understand what quantum physics really means before we ask too much of it. And in the next part, that is exactly where we will go. Because once we have seen how strange the quantum world can be, the next question becomes impossible to avoid. If matter at its deepest level behaves in such unfamiliar ways, then what kind of physical system is the brain? A machine of chemistry? Of electricity? Of biology alone? Or something even more subtle than that, still waiting in the dark for us to understand it more fully? Part 4. The brain as a physical system. If quantum physics makes the universe feel strange, the brain makes that strangeness feel personal. Because out of all the objects we know in the cosmos, the brain may be the one that feels most impossible from the inside. It weighs only a few pounds. It sits in darkness. It never sees light directly, never hears sound directly, never touches the world directly. And yet somehow, from within that sealed and silent organ, a whole reality appears. Color, memory, music, fear, language, longing, dreams, the sense of self, the feeling of being alive at all. It is almost too strange to say plainly. Everything you have ever loved, feared, remembered, imagined, or misunderstood has passed through this physical system. Every story you tell yourself about your life, every face you know, every private ache, every moment of calm, every nightmare, every idea you have about consciousness itself. All of it depends, in some way we still do not fully understand, on the activity of living tissue inside the skull. And that is why this part matters. Before anyone asks whether the brain might involve something quantum, or whether consciousness reaches beyond ordinary biology, we need to pause and give the brain its due. Because even without quantum theory, even without exotic explanations, the brain is already one of the most astonishing systems in nature. It is not magic, but it is so intricate, so layered, and so dynamic that for most of human history it may as well have been. So let us slow down and look at it carefully, not as a symbol, but as a physical system, a real organ. Wet, electrical, chemical, rhythmic, vulnerable, adaptive. An organ that obeys the laws of biology and physics, and yet somehow gives rise to the inner life we have been talking about. A good place to begin is with humility. The brain is not a machine in the simple mechanical sense, like a clock with neat little gears. It is alive. It is built from cells. It changes from moment to moment. It is shaped by genes, by development, by sleep, by stress, by nutrition, by injury, by memory, by love, by trauma, by learning, by loneliness, by repetition, by age. It is not a fixed device installed at birth and left unchanged. It is constantly revising itself. And still, for all its complexity, the brain is made of matter. That is important to remember. When people hear the word mind, they sometimes imagine something airy or immaterial, something floating above the body. But whatever the mind turns out to be in the deepest philosophical sense, everything we currently know suggests that the brain is its immediate platform. Change the brain, and experience changes. Damage a certain region, and language can be altered. Shift chemistry, and mood can change. Interrupt oxygen, and consciousness fades. Add anesthesia, and awareness disappears. Enter REM sleep, and a dream world blooms. Wake the body, and the stable world returns. Again and again, the evidence points in the same direction. The brain is not just nearby when experience happens. It is centrally involved in producing, organizing, or at least enabling that experience. And yet that simple statement leaves us with a mystery instead of removing one. Because saying the brain enables experience is not the same as understanding how. To see why, let us move one layer down, to the cells themselves. The best known cells in the brain are neurons. People often hear that word and picture something very technical, but the basic idea is beautifully simple. A neuron is a specialized cell that communicates. It receives signals, processes them, and passes signals onward. If you could zoom far enough in, you would see vast numbers of these cells arranged in enormous living networks, each one connected to many others through tiny junctions called synapses. This means the brain is not a single voice. It is a conversation. A colossal, non-stop, many-layered conversation happening in darkness, faster than awareness can follow, involving electrical pulses and chemical messengers moving through networks that never fully sleep. Neurons communicate in at least two major ways. The first is electrical. A neuron can fire an impulse, often called an action potential, which travels along the cell like a brief wave of electrical change. The second is chemical. When that impulse reaches a synapse, it can trigger the release of neurotransmitters, chemical messengers that cross the tiny gap between cells and influence whether the next neuron becomes more or less likely to fire. That may sound dry on the surface, but if you sit with it for a moment, it becomes quietly extraordinary. Thoughts are not little ghosts moving through the brain. They are patterns in living matter. Emotions are not floating abstractions. They are embodied processes, shaped by circuits, hormones, memory, bodily signals, and chemistry. Even something as seemingly soft and private as a mood depends in part on this restless biological dance. And the dance never fully stops. Even now, as someone listens late at night, perhaps already drifting a little, neurons are firing. Signals are passing. Networks are integrating sensory input, background memory, body state, and internal prediction. The brain is not waiting for life to happen. It is actively constructing what life feels like from moment to moment. That word, constructing, is one of the most important words in modern neuroscience. Because the older picture of the brain was often too passive. It suggested the world simply enters through the senses and gets recorded somewhere inside. But the newer picture is more active, more dynamic, and more surprising. The brain seems less like a camera and more like a prediction engine. In everyday language, that means the brain is constantly guessing. It uses past experience, context, memory, expectation, and incoming data to make its best model of what is happening right now. Then it updates that model when the world disagrees. In this view, perception is not just the registration of raw reality. It is a controlled construction, a running simulation shaped and corrected by sensory input. This helps explain why the world feels so stable even though the data arriving at the brain is incomplete, noisy, and delayed. The eyes do not provide a perfect movie. They jump. They miss things. The ears capture fragments. The body sends signals that must be interpreted. Light takes time. Nerves take time. Processing takes time. And yet your experience of the world feels smooth and immediate. Why? Because the brain is constantly filling in gaps, smoothing transitions, predicting continuity, and selecting what matters. It is doing far more work than consciousness ever reports. This is true in ordinary waking life, but it becomes especially revealing in sleep and dreams. During waking, the brain is strongly constrained by the outside world. Vision, sound, touch, body position, temperature, internal organs, social cues, language, and memory all help keep the model anchored. But during dreams, much of that constraint loosens. The brain keeps generating experience, but now the source material shifts inward. Memory fragments, emotions, expectations, and associative patterns become more influential. The world is no longer being tightly corrected by external input. That is why dreams can feel so real while being so unstable. The world-making machinery is still running. The brain is still constructing a lived experience. But the usual reference points have weakened. The result is not nothingness, but another reality, one that may be fluid, emotional, symbolic, and impossible by daytime standards. And already, without invoking any exotic theory, the brain begins to look astonishing enough. Because what we are describing is a physical organ capable of producing not one kind of reality, but several modes of reality. Waking, dreaming, daydreaming, lucid dreaming, focused attention, dissociation, deep sleep, drug-altered states, meditation, delirium, each with its own texture, each rooted, at least in part, in shifting brain activity. That activity is not random. It has rhythms. This is where brainwaves enter the story. Now, brainwaves can sound more mystical than they really are, so let us keep them grounded. They are not magical fields floating around the head. They are patterns of synchronized electrical activity across populations of neurons. When many neurons fire in coordinated ways, those rhythms can be detected and described. Different patterns are associated with different states of mind and sleep. During deep, dreamless sleep, slower rhythms tend to dominate. The brain enters a more synchronized, heavy, restorative mode. During lighter sleep and REM sleep, the activity looks different, often more mixed, faster, and in some ways surprisingly similar to wakefulness. That is one reason REM sleep fascinated scientists so much when it was first studied carefully. The body lies still, yet the brain may become vividly active. In some respects, It is a kind of inner wakefulness. This matters because it reminds us that consciousness is not tied to one simple global setting. The brain does not merely switch between on and off. It changes pattern, coordination, and mode. And these modes affect what kind of self can exist. During ordinary waking life, a good deal of brain activity supports orientation to the outer world. Where am I? Who am I? What time is it? What matters right now? What should I do next? But in dreams, that stable self-model often loosens. Time distorts. Identity blurs. Place changes without warning. Dead relatives speak. Houses become oceans. Childhood classrooms become train stations. And somehow the dreaming mind accepts it, because the brain systems responsible for critical monitoring and stable reality checking are not operating in quite the same way. Here again, the brain reveals itself not as a static computer, but as a shifting biological ecology. Different networks rise and fall in influence. Emotion may intensify while logic softens. Visual imagination may bloom while muscle output is suppressed. Memory may fragment while narrative continues. The brain is not just active, it is reorganizing the kind of mind that becomes possible in that state. Now, one might ask, if the brain is a physical system, why does it feel so unlike other physical systems? Why does a liver not seem mysterious in the same way? Why not a kidney or a lung? Part of the answer is that the brain is unusual because it is both the object we study and the instrument doing the studying. A telescope does not wonder about itself. A microscope does not become anxious about its own existence. The brain, however, is a system trying to understand the system through which understanding happens. It is folded back on itself. That alone creates a special kind of mystery. But there is more. The brain is also massively interconnected. No single neuron contains a thought. No one synapse stores a whole personality. The things we care about, love, identity, mood, memory, attention, imagination, arise from patterns distributed across many regions and many timescales. This makes the brain difficult to reduce to tidy one-to-one explanations. People sometimes want neuroscience to work like this. Here is the spot for love. Here is the spot for fear. Here is the spot for dreaming. And sometimes there are regions strongly involved in those functions. The amygdala matters for emotional salience and fear. The hippocampus matters deeply for memory formation. The brainstem helps regulate arousal and sleep-wake states. The visual cortex helps construct vision. Frontal networks matter for planning, inhibition, and self-monitoring. All of that is true. But the deeper truth is networked. A memory is not simply stored in one little box. A dream is not printed in one single region. A conscious moment is not likely the work of one lonely spot glowing in the dark. Experience emerges from coordination across systems. The brain is less like a set of isolated rooms and more like a city at night, with neighborhoods, traffic, signals, power grids, and patterns of activity that only make sense when seen together. This is one reason injury can produce such surprising changes. Damage to one region may alter language while leaving intelligence mostly intact. Another injury may preserve language but change emotional regulation. Sleep deprivation may leave someone technically awake but mentally fogged, emotionally brittle, and perceptually altered. A seizure may briefly distort perception. A stroke may rearrange entire aspects of personality or awareness. Subtle chemical changes can lift or darken a mood. Hormones can alter perception. Fever can change consciousness. So can trauma. So can love. So can grief. All of that reminds us that the mind is embodied more deeply than we often admit. The brain is not floating alone, like a sealed command center disconnected from the body. It is in constant conversation with the body. Heart rate, breathing, immune signals, gut chemistry, stress hormones, posture, pain, fatigue, temperature, hunger, and circadian rhythm all influence what kind of mind becomes possible. A tired brain is not the same brain. A frightened brain is not the same brain. A nourished brain, a sleep-deprived brain, a grieving brain, an inflamed brain, a developing brain, an aging brain, these are not identical platforms on which the same mind simply happens to appear. The body is part of the equation. That becomes especially clear in sleep science. If the brain is deprived of sleep long enough, attention weakens, emotional regulation suffers, memory worsens, perception changes. In extreme cases, even the boundary between waking and dreaming can blur. A person may hallucinate. Reality itself can start to feel unstable. That is not because some mystical substance has left the body. It is because the physical system that sustains coherent consciousness has been pushed out of balance. And yet the opposite is also true. Under the right conditions, the brain is remarkably plastic. Plasticity is another word worth keeping. It means the brain can change with experience. Connections can strengthen or weaken. Skills can be learned. Habits can become easier or harder. Therapy can alter emotional response. Repetition can reshape pathways. Meditation can influence attention and self-monitoring. Trauma can leave lasting marks, but healing can also reorganize patterns over time. The brain is not infinitely flexible, and not every wound can be undone, but neither is it frozen. This living changeability is one of the most hopeful things about it. It means your brain is not merely a prison of old patterns. It is a history, yes, but also a possibility. At the same time, that plasticity makes the brain harder to understand. Because the system doing the thinking is altered by what it repeatedly thinks, attends to, remembers, and rehearses. The observer and the observed are constantly shaping one another. If this is helping you settle deeper into the night, this is a gentle place to like the video, subscribe, or leave a quiet comment about where you're listening from. It is always nice to imagine these thoughts traveling into different rooms, different cities, different little pockets of sleeplessness around the world. Now, there is a temptation at this point to take the brain's complexity as evidence that ordinary biology is not enough. To say, surely something this mysterious must require a mysterious explanation. But that does not necessarily follow. In fact, one of the most important things this part should leave you with is the opposite insight. The brain is already extraordinary enough to generate wonder without any need to rush past biology. Neurons, chemistry, rhythms, plasticity, prediction, memory, embodiment, sleep cycles, and distributed networks already give us a system of breathtaking complexity. The real mystery is not that the brain looks too simple for consciousness. The mystery is that a material organ of this kind can give rise to anything like experience at all. That is the real pressure point. We can describe the parts. We can map circuits. We can correlate states with patterns of activity. We can observe how dreams relate to REM sleep, how attention relates to frontoparietal networks, how memory depends on hippocampal function, how emotion engages specific systems, how anesthesia alters global integration, how sleep deprivation destabilizes experience. All of that matters. All of it is real progress. But even after all of that, a question remains. Why should all this activity feel like something from the inside? Why should electrical impulses, chemical gradients, cellular signaling, oscillations, and networks produce the warmth of being? The feeling of hearing music, the presence of a dream, the grief of loss, the quiet self-watching thoughts arrive and pass, the vivid inner weather of a night mind drifting between waking and sleep. That gap is what keeps the science honest. The brain as a physical system explains much, but not yet everything. It explains why changing the system changes the mind. It explains why consciousness has biological conditions. It explains how sleep stages alter the style of awareness. It explains why dreaming can happen in one state and vanish in another. It explains why perception is constructed, why memory is fragile, why emotion can override logic, why fatigue changes reality. It explains a great deal. And yet the final leap, from mechanism to experience, remains partly hidden. That is why some people become impatient and go searching elsewhere. Into philosophy, into spirituality, into speculative neuroscience, into quantum theories of mind, into bold attempts to explain the hard problem by reaching beneath classical biology. Sometimes that search is careless. Sometimes it is profound. Sometimes it is both at once. But before we follow it, we should gather what we now know. The brain is a physical organ made of cells. It communicates through electrical and chemical signaling. It forms huge, adaptive networks rather than relying on a single center for thought. It generates rhythms that shift with wakefulness, sleep, and dreaming. It does not passively record reality but actively models and predicts it. It remains deeply entangled with the rest of the body. It changes with experience. And within its changing patterns, consciousness seems to narrow, widen, fragment, sleep, dream, return, and sometimes become aware of itself. That alone is enough to make the brain one of the deepest mysteries in science. Because once you really see it that way, as living matter somehow giving rise to felt experience, you understand why people have looked at the brain and thought, maybe we are missing something. Maybe ordinary biology, though vast, is not the whole story. Maybe the brain's complexity hints at processes subtler than the ones we have already mapped. Maybe its deepest workings still hide in places we have barely learned how to see. And that thought, careful or reckless depending on how it is used, is the bridge to where we go next. Because once the brain is recognized as a physical system of immense complexity, the next question arrives almost on its own. Could ordinary neural activity be enough to explain consciousness completely? Or is that very difficulty the reason some scientists and thinkers began wondering whether quantum mechanics, with all its strange probabilities and deep uncertainties, might matter here after all? Part 5. Why some think quantum mechanics might matter in the brain? By this point, we have walked through two very different landscapes. One was the landscape of quantum physics, where the smallest layers of nature behave in ways that feel uncertain, probabilistic, and deeply unlike everyday life. The other was the landscape of the brain, a living physical system of cells, chemistry, rhythms, and shifting networks, already complex enough to inspire wonder without any help from exotic theories at all. And somewhere between those two landscapes, a question began quietly waiting for us. Not a conclusion, just a question. If the brain is made of matter, and matter at its deepest level is governed by quantum rules, then could those rules matter in some meaningful way for the mind? That question has fascinated people for decades. Sometimes for good reasons. Sometimes for careless reasons. Sometimes because it seems to offer a bridge between physics and consciousness. Sometimes because consciousness still feels like such a hard mystery that people are naturally drawn toward whatever territory looks deepest, strangest, or least familiar. But before we talk about any famous theory by name, before we move into specific proposals, we need to understand something more basic. Why did anyone start thinking this way in the first place? Why did some scientists, philosophers, and curious outsiders begin to suspect that ordinary brain activity might not be the whole story? Why did the idea of quantum mechanics in the brain become tempting at all? The answer begins, as many good answers do, with dissatisfaction. Not dissatisfaction in the dramatic sense. Not people throwing up their hands and saying neuroscience is useless. Far from it. Modern neuroscience has explained a tremendous amount. It has shown how brain injury can change language, memory, emotion, and awareness. It has mapped networks involved in perception, attention, decision-making, and sleep. It has shown that dreams correlate with specific brain states, that anesthesia disrupts consciousness in measurable ways, and that the mind is shaped by the body more intimately than earlier thinkers imagined. That is all real progress. And yet, for some people, something still seemed missing. Because even if neuroscience explains more and more about what the brain does, there remains that haunting question at the center of the whole subject. Why should any of that activity feel like anything at all from the inside? You can describe the motion of signals across neural networks. You can talk about sensory integration, memory consolidation, emotional regulation, and predictive processing. You can identify patterns that appear when someone is awake, asleep, dreaming, or anesthetized. But somewhere inside all those descriptions, the private glow of experience still feels hard to pin down. Why is there a felt world at all? Why does information processing become subjective life? Why should a physical process produce not only behavior, but inner presence? This is the pressure point that makes some people restless. It is not that classical neuroscience has failed. It is that for certain thinkers, it still seems to leave the deepest question untouched, or at least not fully satisfied. You can see this tension in ordinary life if you look at it gently. Imagine someone listening to music late at night. Neuroscience can tell us a great deal about what is happening. Sound waves enter the ear. Hair cells in the inner ear convert vibration into neural signals. Auditory regions process pitch, timing, and tone. Memory links the music to earlier experiences. Emotional systems respond. Hormonal changes may occur. The body softens or tenses. The brain, in a distributed and beautiful way, makes music meaningful. All of that is rich and important. But still, there remains the felt sadness of the melody. The ache. The warmth. The inner atmosphere it creates. The way one note can seem to open a room inside the heart. And some thinkers look at that and say, yes, the mechanisms matter, but why should mechanism ever become atmosphere? Why should circuitry become experience? That is where the temptation begins. Not because quantum mechanics automatically solves that mystery. It does not. But because it already lives in the region where ordinary common sense starts to fail. And when one mystery meets another, human thought naturally wonders whether they are connected. There is another source of temptation too, and it comes from the history of science itself. Over and over, science has discovered that the world is not built the way our first intuitions imagined. Time is not as straightforward as it feels. Matter is not truly solid in the naive sense. The present moment is not as immediate as consciousness suggests. Memory is not a perfect recording. Perception is not passive reception. The self is not as fixed as it seems. And at the smallest scales, the universe behaves in ways that classical imagery cannot comfortably hold. So there is a natural pattern in the human mind. Once we learn that ordinary intuition has already failed us in so many domains, we become more willing to suspect that it might be failing us about consciousness too. And if consciousness already feels elusive, already unlike a simple machine, and if the quantum world is already deeply non-intuitive, then perhaps, some people think, the mind may depend on physical processes subtler than the ones usually described in everyday neuroscience. That is the broad emotional logic behind the idea. But there are also more specific reasons people have gone in this direction. One of them is the brain's sheer complexity. The human brain contains an extraordinary number of interacting parts, but more importantly, it produces unified experience out of that complexity. Somehow, countless local processes do not remain merely local. They come together into a single field of awareness. Color, sound, bodily sensation, thought, emotion, memory, and anticipation appear together in one lived moment. That unity feels mysterious. Not just complicated, but mysterious. Some thinkers began to wonder whether classical descriptions of neural firing alone could ever fully explain such unity. Not because classical systems cannot be complex, of course they can, but because consciousness seems to involve something more than complexity alone. It seems to involve wholeness. A kind of integration that is hard to translate into purely mechanistic pieces without losing the thing itself. Now, that concern may or may not be justified. Plenty of neuroscientists believe classical models can in principle explain integration just fine. But for others, the wholeness of conscious experience hints that something deeper may be involved. Quantum theory, with its strange forms of connectedness, especially entanglement, naturally attracts attention here. Again, not because entanglement automatically means consciousness, it absolutely does not, but because quantum mechanics already contains forms of physical description in which the whole cannot always be understood merely as the sum of independently local parts. And for thinkers troubled by the unity of experience, that resemblance is hard to ignore. Another reason has to do with indeterminacy. The classical mechanical world is often imagined as fully determined. Given enough information, in principle, everything that follows could be predicted. Quantum theory complicates that picture. It introduces probability at a very deep level. It suggests that reality is not always pinned down in the simple, fully deterministic way earlier physics imagined. This appealed especially to thinkers who were uneasy about a fully mechanical view of the mind. If the brain were just a large deterministic machine, then where would novelty come from? Where would freedom come from? Where would genuine openness reside? Some wondered whether quantum indeterminacy might open a space, not necessarily for magical free will, but for a less rigid picture of mind than classical mechanisms seem to allow. This is a delicate point, and it is often mishandled. Randomness is not the same thing as freedom. A decision is not meaningful simply because it contains some unpredictable quantum component. If your choices were random, that would not make them more deeply yours. Still, the presence of indeterminacy at nature's foundations made some philosophers and scientists feel that the old image of the brain as a clockwork device was too crude. Quantum theory seemed to soften the machinery of the universe. And once that happened, people began asking whether the mind might live somewhere in that softened space. A third reason is more philosophical than scientific, but no less important. Classical descriptions tend to work beautifully when talking about external objects. Mass, charge, motion, location, signal flow, energy transfer. They are excellent for describing systems from the outside. But consciousness is unusual because it is known first from the inside. It is first person before it becomes third person. You do not infer your own experience from data. You live it directly. Some thinkers have felt that a framework built mainly for external description may always struggle to capture something fundamentally first person. And because quantum theory already challenged the neat separation between observer and observed in certain interpretations, some people began to suspect that it might contain resources for talking about mind that classical physics did not. This is one place where a lot of confusion enters the public imagination, so it helps to be slow and careful. When people hear that observation matters in quantum mechanics, they sometimes jump to the idea that human consciousness creates reality. That is usually much too crude. In actual physics, observation generally means interaction that yields a definite outcome, not a magical human gaze. You do not need a person peering dramatically at an electron for quantum events to occur. And yet, even after all those clarifications, the philosophical unease remains. Quantum theory still seems to place knowledge, measurement, and physical reality into a subtler relationship than classical thinking did. For people already wrestling with consciousness, that subtlety becomes irresistible. And this is how the bridge starts forming. Not from proof, from pressure. Pressure from the hard problem of consciousness. Pressure from the unity of experience. Pressure from dissatisfaction with crude determinism. Pressure from the odd role measurement plays in quantum theory. Pressure from the feeling that neither everyday common sense nor simple mechanical imagery quite reaches the deepest layer of mind. There is also a more specifically biological reason some thinkers became interested in this possibility. The brain is not just a network of abstract signals. It is a physical structure made of molecules, proteins, membranes, ions, tiny architectures inside cells, and highly organized microscopic processes. So even if most neuroscience is described at the level of neurons and networks, the actual substrate of the brain includes much smaller scales. That fact led some people to wonder whether important processes relevant to consciousness might be happening beneath the level of ordinary neural description. In other words, maybe neurons firing are not the whole story any more than weather maps tell the whole story of air molecules. Maybe the familiar scale of brain science captures part of what is happening, but not all of it. This thought became especially attractive because consciousness seems both global and fragile. A tiny chemical change can alter it. A small lesion in one area can distort it. A brief electrical disruption can interrupt it. A sleep state can transform it into dreaming. Consciousness seems at once robust enough to structure a whole world and delicate enough to be reshaped by minute changes. That dual character made some thinkers suspect that the key processes involved might lie deeper than ordinary large-scale brain activity alone. Now, whether that suspicion is correct is another matter. But you can feel why it arose. There is also something almost emotional beneath all this, a kind of intellectual longing. People do not merely want consciousness explained. They want it explained in a way that feels equal to its strangeness. And classical descriptions, however successful, sometimes feel too dry to people encountering the mystery from the inside. Neural correlates, signal cascades, feedback loops, predictive coding. These are important, but for some minds they still feel like the outside of the story, not the inside. They feel like the mechanics of a violin without the music of hearing one at night. So the appeal of quantum ideas is partly conceptual and partly emotional. Quantum physics already carries the aura of depth, subtlety, and mystery. It feels like a place where ordinary logic loosens. And consciousness also feels like that. So the mind reaches for the possibility that two mysteries may illuminate one another. This is very human. It is not foolish to ask such questions. But it is very easy to become careless with them. That is why this part has to stay balanced. Because there are strong reasons to wonder whether quantum mechanics might matter in the brain, but there are also strong reasons for caution, and we should keep both in view from the very beginning. One reason for caution is scale. Quantum effects are easiest to observe in very small, isolated systems. But the brain is not small in that sense. And it is certainly not well isolated. It is warm, wet, noisy, active, metabolically intense, and in constant interaction with its environment. Those conditions tend to destroy delicate quantum states very quickly through decoherence. If someone proposes that quantum processes play an important role in consciousness, they must explain how such processes could survive long enough, and remain organized enough, to matter in a brain like ours. That is not impossible in principle. But it is not something you get for free merely by saying, the brain is made of atoms. Everything is made of atoms. That alone does not make consciousness a quantum phenomenon in any interesting sense. Your coffee cup is made of atoms too. So is a rock. The relevant question is not whether the brain is ultimately physical. Of course it is. The question is whether specifically quantum effects do meaningful explanatory work at the level of mind. That is a much harder claim. Another reason for caution is that quantum can become a placeholder for confusion. Whenever we do not understand something, there is a temptation to fill the gap with a mysterious word and let that word do emotional work instead of explanatory work. This happens all the time in popular culture. Quantum healing, quantum spirituality, quantum manifestation, quantum consciousness used almost like incense, filling the room with a mood of significance while saying almost nothing specific. Science has to resist that. A real theory must do more than sound deep. It must specify mechanisms, make testable claims, and survive criticism. It must explain more than existing theories, or at least illuminate something existing theories genuinely fail to explain. So if quantum ideas are going to matter in brain science, they must matter in that stricter sense. Still, the temptation remains, and perhaps it should, because temptation is sometimes where new science begins. Not in certainty, but in persistent, intelligent discomfort. And discomfort certainly exists here. Neuroscience can tell us which networks light up during certain tasks, but it does not yet tell us why awareness itself should arise. It can correlate dreaming with REM sleep and particular cortical dynamics, but it does not fully tell us why a dream should feel like an inhabited world. It can model decision-making and perception with increasing sophistication, but the sheer existence of subjective experience still seems to exceed the comfort zone of purely third-person description. So some thinkers say perhaps we need a deeper level of physics to understand a deeper level of mind. Whether they are right is still unresolved. But notice how modest that statement is. Not quantum theory proves consciousness is cosmic. Not science has already shown the brain is quantum. Only this: some thinkers suspect that classical neuroscience may not be enough, and quantum mechanics has seemed to them like one possible place to look. That is the honest version. There is another subtle reason the idea persisted, and it has to do with the boundary between the mental and the physical. Most of us live as if these are obviously distinct categories. The physical is matter, energy, space, motion. The mental is thoughts, feelings, dreams, meanings, inner life. But that neat separation starts to wobble when you examine it closely. Thoughts change the body. Bodily states change thought. Perception is built by physical processes but lived as experience. A dream can produce genuine fear even when the threatening event is entirely imagined. A memory can raise the heart rate. An expectation can change pain. A placebo can alter physiology. Meaning is somehow carried by matter, yet not reducible to matter in any simple everyday way. For some thinkers, this boundary problem suggested we may need conceptual tools more subtle than classical physical description alone. Quantum theory, being already less intuitive and more relational than old mechanical models, seemed like it might offer those tools. Again, this is not proof. It is a direction of thought. And perhaps that is the best way to understand this whole chapter. Part 5 is not here to convince you that quantum mechanics really does explain consciousness. It is here to explain why people even started considering that possibility. Why the idea kept returning. Why it still has a strange hold on the scientific imagination, even among people who remain skeptical. The answer is not one single thing. It is many gentle pressures converging. The hard problem of subjective experience. The unity of consciousness. The inadequacy of simple mechanical intuitions. The non-classical nature of matter at fundamental scales. The indeterminacy of quantum theory. The subtle relationship between observation and physical outcome. The possibility that relevant processes in the brain may occur below the scale of familiar neural description. And perhaps, beneath all of it, the lingering sense that the mind is too strange to be fully captured by our first explanations. If this calm exploration is helping you drift a little deeper tonight, you can gently like the video, subscribe, or leave a comment with the question you keep returning to most in this series. Sometimes the comments are as interesting as the script itself, because they reveal which mysteries people quietly carry into the night. Now, as we let this part settle, there is one final thought worth holding before we move on. Sometimes, when science has not yet solved a mystery, there are two equal and opposite mistakes people make. The first mistake is to say, we do not understand it yet, therefore it must be something mystical, unreachable, or beyond science forever. The second mistake is to say, we have a lot of partial explanations already, therefore the deepest mystery is basically solved. Both are forms of impatience. The wiser position is harder and gentler. It is to stay in the uncertainty honestly. To say, the brain is an extraordinary physical system, and classical neuroscience explains a great deal. But consciousness remains deeply puzzling. Quantum theory is one possible place some thinkers have looked for additional insight, not because it is automatically right, but because the mystery remains open enough to keep thoughtful people searching. And that open space is where we are now. We have reached the point where the question becomes more concrete. No longer just, why would anyone think quantum mechanics matters in the brain? But who, exactly, has tried to say how it might matter? What theory did they actually propose? What mechanisms did they point to? And why have those ideas become so famous, so controversial, and so difficult to ignore? That is where we go next. Because once the temptation has been explained, the names begin to appear. And with them, one of the most well-known and debated attempts to connect quantum physics, the brain, and consciousness in a single bold theory. Part 6. The famous quantum consciousness theories. There comes a moment in almost every deep conversation about consciousness when the tone shifts. Up to a certain point, the questions feel grounded in familiar science. Neurons, sleep, brainwaves, perception, memory, attention. These are difficult subjects, but they still belong to a world that feels reachable, a world of laboratories, scans, and measurable patterns. Then, very quietly, another kind of question enters the room. What if all of that is still not enough? What if the brain is not only biological, but in some important way also quantum? What if consciousness, instead of being merely an emergent property of ordinary neural activity, depends on something stranger, something deeper, something hidden in the smallest physical structures of the brain? That is the point where the atmosphere changes. Not because everyone suddenly agrees. Far from it. In fact, this is exactly where debate becomes most intense. But it is also where the imagination of science becomes especially visible. Because once people begin to suspect that consciousness may not be fully explained by ordinary brain processes alone, they start looking for theories bold enough to meet the mystery at its own level. And this is where the famous names appear. Not all at once. Not with one single clean answer. But with a handful of proposals, some more philosophical, some more mathematical, some more biological, all attempting in their own ways to do something very difficult. To connect the weirdness of quantum physics with the private, living reality of conscious experience. Tonight, we are not going to treat these theories as proven. That would be careless. But we are also not going to dismiss them as nonsense just because they sound unusual. That would be careless too. Instead, we are going to walk through them gently, with the same calm patience we have used for everything else in this journey. We will ask what these theories are trying to explain, what they claim is happening, and why they have remained so compelling to some people even while many others remain deeply skeptical. And the best place to begin is with the most famous theory of all, the one most closely associated with the phrase quantum consciousness. The theory is usually known as OR, short for orchestrated objective reduction. Even the name sounds dense, a little metallic, a little unfriendly. But beneath it is a surprisingly human story. A story of two thinkers from very different worlds trying to answer the same mystery. One was Roger Penrose, a mathematical physicist with a deep interest in the foundations of reality, especially the question of whether ordinary computation could ever fully account for human understanding. The other was Stuart Hameroff, an anesthesiologist who had spent years thinking about the fine structures inside brain cells and what role they might play in consciousness. Together, they proposed one of the boldest ideas in modern thought about the mind. The basic suggestion was this: consciousness does not arise solely from the usual firing of neurons in the ordinary classical way. Instead, it may depend on quantum processes taking place inside tiny structures within neurons called microtubules. Now, before that word microtubules disappears into the fog, let us hold it for a moment. Microtubules are real biological structures. They are part of the internal scaffolding of cells. They help cells keep their shape, transport materials, and organize internal processes. They are not speculative. They are not invented for the theory. They are there. What Penrose and Hameroff suggested was not merely that microtubules exist, but that they might support delicate quantum states, and that these states could play a role in conscious moments. That is the biological side of the theory. The other side comes from Penrose's thinking about physics and computation. He was not convinced that ordinary algorithmic processes, the kind a computer might follow step by step, could fully explain human understanding or consciousness. He believed there might be something non-computational involved, something rooted in the physics of reality itself. From that starting point, he proposed that quantum state reduction, the transition from quantum possibilities to definite outcomes, might not be merely a matter of observation in the usual sense, but could involve an objective physical process tied to the structure of spacetime itself. That phrase, objective reduction, refers to the idea that quantum superpositions do not remain indefinite forever. At some point, according to Penrose, they collapse or reduce due to an intrinsic instability related to gravity and spacetime geometry. In simple terms, he suggested that the universe may not allow certain large or significant superpositions to persist indefinitely. They resolve themselves into definite states. Hameroff and Penrose then combined these ideas. If quantum states could arise and persist, even briefly, inside microtubules in the brain, and if their objective reductions were somehow organized by biological activity, then perhaps each such event might correspond to a moment of conscious experience. Consciousness, in this picture, would not simply be neurons firing in the ordinary way. It would be something more layered. Neural activity would help orchestrate quantum processes, and those quantum processes would culminate in moments of awareness. That is the broad idea. If you listen to it slowly, without rushing to accept or reject it, you can hear why it captivated so many people. It offered a bridge between three things that had long seemed difficult to reconcile: the deep weirdness of quantum mechanics, the stubborn mystery of subjective experience, and the extraordinary biological sophistication of the brain. It gave people a story in which consciousness was not just an accidental side effect of computation, nor a ghost outside the physical world, but something rooted in the deepest physical structure of reality and organized through living biology. That is a very powerful image. It also explains why the theory drew so much attention outside science. It sounded like an attempt to honor the strangeness of consciousness rather than flatten it into dry mechanism. It treated awareness not as an illusion to be explained away, but as something physically fundamental enough to deserve a theory at the level of quantum reality itself. And yet, for all its beauty and ambition, OR has never been widely accepted as established science. Why? Because a beautiful idea is not the same thing as a demonstrated one. The biggest challenge has always been this: the brain is warm, wet, noisy, and metabolically busy. Those are not ideal conditions for fragile quantum states to survive. Many physicists and neuroscientists argue that if quantum coherence is to matter in the brain, it would need to persist long enough, and in an organized enough way, to influence large-scale neural function. And they remain unconvinced that microtubules can do this. Critics have argued that the relevant quantum states would decohere far too quickly, long before they could play any meaningful cognitive role. Others have questioned whether the mathematics of the theory really maps convincingly onto the biology of the brain. Still others simply note that the theory, while imaginative, has not yet produced decisive evidence that consciousness truly depends on these processes. That criticism matters. It matters because it keeps the theory honest. At the same time, supporters of the theory have not simply vanished. Some continue refining the proposal, pointing to suggestive findings, possible quantum effects in biological systems, and the need to keep an open mind about what kinds of coherence may be possible in living matter. After all, biology has surprised science before. There are biological systems, such as certain processes in photosynthesis, where quantum effects appear to play a role in ways once thought unlikely. That does not prove the same for consciousness, but it keeps the door from closing entirely. And this is the atmosphere in which OR still lives. Not established fact. Not dead fantasy. Something more awkward and interesting. A theory at the edge of disciplines, still discussed because the problem it tries to solve remains unsolved. Now, OR is the most famous theory, but it is not the only one people invoke when talking about quantum consciousness. Long before that theory took shape, there were already thinkers wondering whether consciousness might play a role in quantum measurement itself. This brings us to a more philosophical family of ideas, often linked, in public conversation at least, to names like John von Neumann and Eugene Wigner. The simplest version of this idea goes something like this. Quantum mechanics describes systems as existing in a spread of possibilities until measurement yields a definite outcome. But what exactly counts as a measurement? What turns possibility into actuality? Some thinkers wondered whether consciousness itself might be involved in that transition. This became, in popular language, the idea that consciousness collapses the wave function. Now, that phrase has traveled very far from its original context and picked up a lot of baggage. It is often repeated with much more confidence than caution. So let us be careful. The serious version of the question is not simply, your mind creates reality because you looked at it. It is subtler. It asks whether the chain of physical interactions in quantum measurement ever truly becomes definite without some connection to conscious observation. Von Neumann explored the measurement problem in a rigorous way, tracing how measuring devices themselves are also physical systems and thus, in principle, part of the same quantum chain. Wigner later entertained the possibility that consciousness might mark a special boundary in that chain. This is philosophically fascinating because it seems to place the observing mind inside the basic structure of physical theory rather than outside it. But it is also highly controversial. Most working physicists do not treat consciousness collapse ideas as necessary to do quantum mechanics. Many interpretations of quantum theory do not require any special role for human awareness at all. Measurement can be understood as interaction, decoherence, branching, or other processes depending on the interpretation. In that sense, consciousness collapse ideas remain more a part of philosophical debate than mainstream neuroscience or physics. Still, these ideas matter in the story because they planted an enduring suggestion in the culture of thought. If consciousness and quantum measurement are connected even in principle, then perhaps the mind is not just another late byproduct of matter. Perhaps it occupies a more central place. That possibility has been enormously seductive, especially to people who feel that ordinary materialism leaves consciousness looking too secondary, too accidental, too diminished. But again, seduction is not evidence. These theories remain famous not because they have been decisively proven, but because they dramatize a real pressure point. They are attempts to answer a question science still has not fully settled. What kind of thing is consciousness, if it can be both physically dependent and phenomenally unique? There are also other, less famous quantum mind proposals that orbit around similar questions. Some theorists have speculated about quantum coherence in broader neural systems, not just microtubules. Others have drawn on the work of physicist Herbert Froelich, who suggested that biological systems might under certain conditions sustain coherent excitations, though whether such ideas connect meaningfully to consciousness remains highly uncertain. Still others have proposed models where quantum processes influence neural timing, synaptic events, or other microphysical aspects of brain function that might, in aggregate, matter for awareness. These proposals vary widely in quality and rigor. Some are careful and mathematically motivated. Others are loose and more speculative. But they share a common mood. A suspicion that the explanation for consciousness may lie deeper than standard classical descriptions, and that quantum theory might offer access to that deeper level. If you step back from the details, a pattern becomes visible. Nearly all of these theories are trying to do at least one of four things. First, they are trying to explain why consciousness feels so unlike ordinary computation. Second, they are trying to account for the unity or wholeness of experience. Third, they are trying to avoid a picture of mind that feels too mechanically closed, too deterministic, too blind to the first-person quality of experience. And fourth, they are trying to place consciousness somewhere more central within the architecture of reality. That does not make them right, but it does explain why they endure. Because each of those pressures is still with us. Consciousness still does not feel like mere calculation. Experience still does arrive as a unified field. Mechanistic explanations still leave some people unsatisfied. And the relationship between awareness and physical reality still feels unfinished in the sciences. It is also worth noticing how differently these theories speak to different audiences. To some scientists, they are overreaches, examples of the mind rushing toward mystery whenever explanation becomes difficult. To some philosophers, they are brave attempts to keep science open to the depth of the problem. To some general audiences, they become almost mythic, stories that seem to validate the intuition that mind is more than mechanism. To others, they are cautionary tales about how easy it is to confuse unresolved mystery with explanatory progress. And perhaps all of those reactions tell us something. Because when a theory becomes famous before it becomes well established, it usually means it has touched not only a technical question, but an emotional one. It has entered a region where science, philosophy, and human longing overlap. Quantum consciousness theories do exactly that. They are not just technical models. They are also responses to a certain unease. An unease many people feel when they are told that the mind is nothing but ordinary matter in motion. Not because matter is unimportant, but because ordinary descriptions of matter seem too pale beside the vividness of experience itself. The irony, of course, is that matter has already turned out to be far less ordinary than earlier science assumed. And that is part of what keeps these theories alive. They feed on the fact that quantum physics already shattered our simple image of reality. Once that image is gone, it becomes harder to insist with total confidence that consciousness must be simple too. Still, even here, caution is a form of respect. We should respect the mystery enough not to flatten it, but also enough not to fake an answer. So let us gather what we actually have. We have OR, the Penrose-Hameroff theory, which suggests that orchestrated quantum processes in microtubules may culminate in conscious moments through objective reduction. It is the most elaborate and famous quantum consciousness theory, and also one of the most criticized. We have consciousness collapse interpretations associated with the measurement problem in quantum mechanics, where some thinkers wondered whether awareness itself helps turn possibility into actuality. These ideas are philosophically rich, historically important, and still controversial, but far from standard consensus. We have a wider cloud of proposals about coherence, microphysical processes, and non-classical effects in biology, all motivated by the hope that the brain's deepest workings may involve quantum phenomena in ways still poorly understood. And around all of them we have the same unresolved tension. Theories bold enough to match the mystery, but evidence not yet strong enough to settle the case. If this quiet exploration is keeping you company tonight, you can gently like the video, subscribe, or leave a comment about which theory feels more plausible to you. The idea that consciousness emerges fully from ordinary neural complexity, or the possibility that some deeper physical layer still matters. These are the kinds of questions that make the dark feel a little more thoughtful. Now, before we leave this part, there is one more thing to say, and it matters a great deal. These theories are often treated as if they either save consciousness from reductionism or expose science as incomplete in some dramatic way. But perhaps that framing is too dramatic. Perhaps what they really reveal is something quieter. They reveal that consciousness remains hard enough to explain that even serious thinkers are willing to explore paths once considered almost unthinkably strange. That does not mean the paths are correct, but it does mean the problem is real. And in a way, that should humble everyone, the skeptics and the enthusiasts alike. Because the real lesson of these theories may not be that consciousness is definitely quantum. It may be that the science of mind is still young enough, and the mystery deep enough, that we do not yet know which kinds of explanation will ultimately survive. Maybe classical neuroscience will keep advancing until quantum theories become unnecessary. Maybe some subtle quantum contribution will one day be demonstrated. Maybe the answer will turn out to be neither of those in the forms we currently imagine. For now, we remain in the most honest place possible. Interested, careful, unconvinced, and still listening. And that, perhaps, is exactly where science does its best work. Because once the boldest theories are on the table, once their beauty and their fragility are both visible, the next step becomes inevitable. We have to ask not only why these theories were proposed, or what they claim, but whether they actually hold up under criticism. Is the brain really the kind of place where meaningful quantum coherence could survive? Are these theories solving the hard problem, or simply moving the mystery into a smaller room and giving it more exotic furniture? What do mainstream scientists say in response? And if so many people remain skeptical, why? That is where we go next. Because whenever an idea is this famous, this ambitious, and this controversial, the real test begins not in the beauty of the theory, but in the resistance it meets from the world. Part 7, Dreams, Memory, and the Strange Logic of the Sleeping Mind. There is a moment that happens in certain dreams when everything feels completely convincing. You are standing in a house you have never seen, yet somehow you know it is your childhood home. A person you have not thought about in years is speaking to you with the voice of someone else. A hallway opens into a beach. A dead relative is alive again, and in the dream this does not feel impossible. It does not even feel unusual. It simply feels true. And perhaps that is one of the strangest things about dreaming. Not just that dreams are bizarre, but that while they are happening, the mind accepts them so easily. It moves through broken logic with a kind of soft obedience. It lets time bend. It lets identity blur. It lets one place become another without protest. The waking mind, if it were there in full strength, would stop and object. It would say, "This makes no sense." But the dreaming mind is gentler than that, more fluid, more symbolic, more willing to live inside strange arrangements of memory and feeling. Tonight, we are going to stay with that strangeness. Not to decode every dream as if it were a secret message with one fixed meaning. And not to turn dreaming into pure fantasy either, as if it were nothing more than random noise. Instead, we are going to look at dreams as one of the most revealing windows into how the mind handles memory, emotion, and reality when the usual rules grow quiet. Because dreams are not only stories, they are evidence. Evidence that the sleeping mind can build whole worlds from fragments. Evidence that memory is not a static archive, but a living material. Evidence that logic, identity, and time are more flexible than the waking self likes to believe. And evidence too that consciousness, even in sleep, remains active enough to turn half-forgotten traces into lived experience. The deeper you look at dreaming, the less it feels like a meaningless side effect of sleep. It starts to feel more like the mind talking to itself in a language older than reason. And that language is made of memory. A useful place to begin is with something simple. Most dreams do not come from nowhere. They may feel sudden, but they are built from material the mind already has. Faces, places, words, fears, longings, unfinished tensions, bodily sensations, emotional residues from the day, old scenes from childhood, things half heard, things barely noticed, hopes that were not admitted in daylight, worries too diffuse to name. The dreaming mind gathers these things with extraordinary freedom and rearranges them. That is why dreams often feel both new and familiar at once. You may dream of a city you have never visited, yet parts of it clearly belong to streets you once walked. You may speak to a stranger whose face is strangely assembled out of several people you know. You may dream of school decades after leaving it, not because the classroom itself matters, but because some emotional pattern from the past has become useful to the dreaming brain again. Dreams are rarely photographic records. They are more like collages. The mind cuts pieces from memory and feeling, then pastes them into temporary worlds. Some pieces remain recognizable. Others are transformed beyond easy recognition. But underneath the shifting imagery, memory is almost always there, supplying texture, tone, and emotional gravity. This matters because many people imagine memory as a kind of storage shelf. You place experiences there, and later retrieve them. But memory is not that still. Even in waking life, memory is reconstructive. Each act of remembering is also an act of rebuilding. And in dreams, that rebuilding becomes even freer. A dream may take the emotional truth of a memory without preserving its surface details. Or it may keep the place but change the people. Or keep the feeling but invent a new story around it. The result is not always a hidden code to be solved. Sometimes it is simply the sleeping mind doing what it does best, reworking experience into forms that can still be felt. And this is where dreaming becomes so interesting scientifically. Because one of the major ideas in sleep science is that sleep helps the brain process memory. Not in a mechanical filing cabinet way, but in a dynamic and living way. During sleep, especially across different stages, the brain appears to revisit, reorganize, strengthen, weaken, and integrate information from waking life. Some traces are reinforced. Some are softened. Some are connected to older material. Some may be stripped of a little of their emotional charge. Some may be woven into longer narratives of who we are. If that is true, then dreams may sometimes be what this inner work feels like from the inside. Not always in a literal sense. The dream is not necessarily the memory process itself in a one-to-one way. But it may be one visible expression of a brain busily recombining the raw material of a life. Think of what happens after a long, emotionally heavy day. You may go to sleep still carrying the atmosphere of it in your body. A conversation that unsettled you. A mistake that keeps echoing. A face you cannot stop replaying in your mind. Then, during the night, those elements begin to mutate. The conversation becomes a trial, or a train station, or an endless exam you forgot to prepare for. The emotional pattern survives, but the narrative shape changes. That is one of the hallmarks of dreams. They preserve importance more faithfully than detail. In other words, the sleeping mind often asks not what happened exactly, but what mattered. What felt unresolved. What carried fear, desire, shame, wonder, grief, longing, urgency. That emotional core may be what dreams protect most carefully, even while the scenery shifts around it. And that helps explain why dreams are often strange but not meaningless. Their logic is not the logic of waking events. It is closer to the logic of association. One image calls another. One feeling pulls in an old memory. One place becomes another because they share a mood. A childhood home turns into an office because both contain some common thread of pressure or belonging or vulnerability. A dead grandparent appears in a hospital corridor because grief, memory, and fear have become entangled in the sleeping mind. The dream does not care whether these transitions would satisfy a waking editor. It cares whether the underlying emotional movement remains coherent to itself. This is what I mean by the strange logic of the sleeping mind. Dreams are not usually logical in the daytime sense. But they are not simply random either. They often follow emotional logic, symbolic logic, bodily logic, associative logic. A dream scene may be absurd and still feel perfectly continuous because the emotional current is continuous. The mind knows where it is going, even when the story looks broken from the outside. You can feel this in certain recurring dreams. Many people have them. The exam dream, the falling dream, the dream of being late, lost, chased, trapped, unable to speak, unable to run, unable to find the right room, unable to reach someone who matters. These dreams may take on different settings across the years, but they often circle the same emotional architecture: fear, exposure, helplessness, incompleteness, urgency. The details change, but the pattern remains. That is not how random static behaves. It is how a mind behaves when it keeps returning to unfinished emotional terrain. In some cases, this may reflect stress. In others, deeper memory. In still others, simply the brain's recurring way of rehearsing or metabolizing tension. But whatever the explanation in a specific dream, the repetition itself reveals something important. Dreaming is not merely decorative. It often returns to what the mind has not yet fully settled. This becomes even clearer when we think about how memory and emotion are linked in the brain during sleep. Earlier in the series, we talked about how emotional systems remain active during dreaming, especially during REM sleep, while some of the systems that support strict logical evaluation become less dominant. That creates a fascinating condition. Memory fragments can be vivid, emotion can be strong, but the usual daytime referee, the part of the mind that says hold on, that is impossible, is quieter than usual. The result is a form of consciousness that is sincere but unstable. A dream can feel utterly real while you are inside it because the machinery of belief is still active, but the machinery of skepticism is softened. This is why impossible events are often accepted without resistance. The dream is not trying to pass a logic exam. It is trying to generate an experience. And that experience often tells us something about how the mind organizes itself in the dark. One of the most curious things about dreaming is how it handles time. In waking life, time feels orderly, even when it feels fast or slow. We know what came before and what came after. We can usually place events in sequence. But dreams do not respect that order in the same way. A single dream can feel like it lasted hours, yet unfold in only a few minutes of sleep. A person from one decade of life can appear beside a person from another as if no years separated them. You can be a child and an adult in the same dream without noticing the contradiction. A scene can end and continue somewhere else with no bridge between them. It is tempting to say that dreams distort time, but perhaps it is more accurate to say they reveal how much the sense of time depends on how experience is organized. Dream time is shaped less by clocks and more by narrative intensity, emotional density, and associative movement. A dream moment can stretch because it is rich in feeling. It can jump because memory jumps. It can collapse years because the sleeping mind groups by meaning, not calendar. This is one reason dreams can feel so haunting when you wake from them. They are not bound to the ordinary timeline in the way waking thought is. They can bring the dead into the present without apology. They can restore lost places. They can put your younger self beside your current self and ask the heart to feel both at once. They can make absence feel present, and presence feel gone. In that sense, dreams are not only strange, they are deeply intimate with the way memory actually lives in us, not as neat history, but as layered emotional time. That layered quality is especially clear in grief dreams. Many people who lose someone dear dream of them vividly, sometimes years later. The dream may not explain anything. It may not be symbolically complex. Sometimes the person is just there, sitting at a table, walking through a garden, smiling, silent, alive again in the dream's reality. And the effect can be overwhelming, because for a few moments the sleeping mind does not enforce the finality that waking consciousness must accept. A scientist could say, correctly, that such dreams reflect memory, attachment, and emotional processing. But from the inside, they often feel like something more tender than explanation. They show us that the mind stores relationships not as dead facts but as living structures of feeling. When the ordinary rules of waking life relax, those structures can rise again into experience. Dreams also reveal how unstable identity can become when the mind is left to its own devices. In waking life, we feel relatively continuous. I am me. I have a name, a history, a body, a set of roles. But dreams do not always preserve that stability. You may be yourself in one dream, then shift perspective without noticing. You may feel both observer and participant. You may dream of being someone else, or of watching yourself from the outside, or of moving through places with no clear sense of who the dream self really is. And still, the dream continues. That suggests something quietly radical. The stable waking self, the one that feels so central during the day, may be more constructed than it appears. Dreams show us that the mind can generate conscious experience even when the usual story of I becomes fluid. Experience does not always need a fully coherent narrator in order to happen. It can proceed with partial selves, shifting selves, symbolic selves, or almost no self at all beyond the fact of being present in the dream. And that matters for the science of consciousness too. Because if dreams can sustain vivid experience while loosening the ordinary structure of identity, then the self may not be the foundation of consciousness so much as one recurring pattern within it. A very important pattern, yes, but not an unbreakable one. This may be part of why lucid dreaming feels so unusual. In a lucid dream, some layer of reflective self-awareness returns. Suddenly the dreamer knows, this is a dream. And with that recognition, the whole atmosphere changes. The dream may remain strange, but now there is a waking-like observer present inside it. The dream becomes not just experience, but experience that knows itself as experience. That shift is extraordinary, because it tells us that different layers of mind can be recombined in sleep. Sensory imagination can remain dreamlike. Emotion can remain dreamlike. The world can remain unstable, but self-awareness can partially return. In a way, lucid dreaming reveals that the sleeping mind is not one simple mode. It is a dynamic arrangement of capacities that can appear in different proportions. And again, dreams become evidence. Evidence that consciousness is modular enough to reassemble itself in unusual ways. Evidence that logic, selfhood, memory, and world-building can separate and reunite under different conditions. Evidence that the mind at night is not merely off, but active, flexible, and strangely creative. If this quiet journey through dreams is helping you settle in, this is a gentle place to like the video, subscribe, or leave a comment about a dream that stayed with you for years. Those stories often reveal how much the sleeping mind can carry, even when its language is strange. Now, there is another layer to dreaming we should not overlook, and that is the body. Dreams may feel like pure mind, but the body never fully disappears from the story. A shifting temperature in the room, pressure from a blanket, a full bladder, a racing heart, discomfort in a limb, even the rhythm of breathing can influence dream imagery. Sometimes the sleeping brain weaves these signals into the dream narrative rather than waking you immediately. A distant sound becomes thunder in the dream. A bodily pressure becomes a situation of restraint or urgency. The mind does not merely receive bodily signals. It interprets them, dramatizes them, absorbs them into the current story. This tells us something important. Dreams are not floating free of biology. Even at their most surreal, they remain embodied experiences. The sleeping mind is still a living brain in a sleeping body, responding to internal and external conditions while building its inner world. And because dreams are embodied, they can also be affected by illness, stress, medication, trauma, and sleep disruption. People under great stress often report more vivid or more anxious dreams. Trauma can produce recurring nightmares that feel less like symbolic rearrangement and more like direct return. Certain medications alter dream intensity. Sleep deprivation can make dream boundaries leak into waking. Fever can intensify dream imagery into something almost hallucinatory. This again reminds us that dreams are not detached fantasies. They are expressions of a brain and body moving through real conditions. At the same time, dreams are not simple readouts of those conditions either. They transform. That is perhaps the most essential word for this whole part. Dreams transform. They transform memory into image, emotion into scene, tension into pursuit, desire into impossible geography, grief into visitation, fear into repetition, bodily sensation into symbolic event. They are one of the mind's most powerful engines of transformation. This is why dreams can feel so meaningful even when they resist literal interpretation. Sometimes what matters is not solving the dream like a puzzle, but noticing what the dream keeps returning to, what mood it carries, what unresolved feeling it circles, what part of the self seems to be asking for attention, what memory has become active beneath the surface, what old room in the mind has quietly lit up again. To say this carefully, dreams are not always wise. They are not always profound. Sometimes they are noisy, sometimes silly, sometimes fragmented, sometimes empty of obvious significance. But even then, they still reveal something about the sleeping mind's freedom, its ability to loosen the world, to recombine experience, to create lived realities from emotional and mnemonic fragments. And that ability may matter more than it first appears. Because when we look at dreams closely, we begin to see something important about the waking mind too. We often assume waking life is solid reality and dreaming is distortion. But that contrast may be too simple. Waking consciousness also constructs a world. It just does so under tighter constraints. It uses sensory input, memory, prediction, bodily feedback, and attention to generate an experience that feels stable and shared. Dreams do something similar with fewer external anchors and more internal freedom. In that sense, dreaming does not stand outside the science of consciousness. It helps expose the machinery of consciousness more clearly. It shows us the mind's world-building powers stripped of some of their daytime discipline. It shows what happens when memory, emotion, and imagination are allowed to run in wider circles. That is why the sleeping mind seems irrational only if we judge it by waking standards. By its own standards, it is doing something astonishingly coherent. It is protecting emotional truths, reorganizing memory, testing possibilities, reviving attachments, dramatizing fears, and keeping consciousness active in altered form through the night. The logic is strange, yes, but it is not empty. And perhaps that is the gentlest conclusion for this part. Dreams are not failures of reason. They are another style of reason, one built from association instead of argument, from feeling instead of proof, from symbolic motion instead of linear sequence. They do not always tell the truth in facts, but they often tell the truth in atmosphere. They reveal what the mind cannot fully stop carrying. They reveal that memory is alive. They reveal that time inside us is softer than we think. They reveal that identity can loosen without disappearing. And they reveal that even in sleep, consciousness does not simply vanish. It changes its grammar. When the lights of waking logic dim, the mind keeps speaking, not in the language of the day, but in another language entirely. A language of old rooms and impossible weather, of returning faces and shifting houses, of things feared, things missed, things not yet understood. And somewhere inside that language, the sleeping mind goes on trying to make a world. In the next part, we move one step deeper into that strange territory. Because once we see how dreams are built from memory, emotion, and unstable reality, another question naturally begins to form. If the logic of dreams already feels so fluid, so uncertain, so almost untethered from ordinary rules, could that be why some people are tempted to compare dreaming with the strange uncertainty of quantum physics itself? Not because the two are the same, but because both seem to live in places where certainty softens, reality shifts, and the world becomes harder to pin down. Part 8. Could quantum weirdness resemble dream experience? There is a certain kind of dream that leaves behind an aftertaste. Not always fear, not always beauty. Something stranger than that. A feeling that, for a few minutes after waking, reality itself has become slightly less solid. The room is still there. The walls are still where they were. Morning or night still moves on. And yet part of the mind has not completely let go of the world it was just inhabiting. A world where one person could be several people at once. A world where a place could be both familiar and impossible. A world where time moved, but not in a straight line. A world where things did not obey reason, but still obeyed some deeper kind of pattern. And if you stay with that feeling long enough, a quiet thought begins to form. Not a conclusion, just a thought. The logic of dreams sometimes feels strangely similar to the kind of world quantum physics describes. Not in the literal, scientific sense, at least not as something we can honestly prove. We should be careful from the beginning. Dreams are not known to be quantum mechanics acting as theater. And quantum physics is not a poetic metaphor invented to make dreams sound profound. They are different domains. One belongs to the science of matter at very small scales. The other belongs to the lived experience of a sleeping mind. But sometimes two very different things can still resemble one another in mood. And that resemblance can be revealing. Because both quantum physics and dreaming seem to disturb the same instinct inside us, the instinct that reality should be stable, singular, and clearly defined at all times. Both seem to whisper that the world, or at least the world as it appears to us, may be less fixed than we assume, less tidy, less obedient to the hard lines of waking common sense. So tonight we are not trying to prove that dreams are quantum. That would be too much, and too careless. What we are doing instead is quieter than that. We are asking whether the strange feel of dreaming might help us emotionally understand why quantum physics unsettles us so deeply. And in the other direction, whether the strange features of quantum physics might offer a useful mirror, not a proof, but a mirror, for some of the fluidity, uncertainty, and instability we experience in dreams. Because sometimes parallels do not solve a mystery. They simply help us feel its shape more clearly. A good place to begin is with certainty. Waking life depends heavily on the impression that the world is definite. A chair is here, not there. A person either entered the room or did not. The cup is full or empty. The day is Monday or Tuesday. A conversation either happened or it did not. Even when memory is imperfect, waking consciousness is built around the expectation that reality itself is sharply there, waiting to be known. Dreams soften that. In a dream, the world often does not begin as definite in the ordinary way. It begins more like an atmosphere that gradually becomes itself. A place appears before its geography settles. A person arrives before their identity becomes clear. A scene can hold several meanings at once without choosing between them. You are in a school, but also in a hospital, but also somehow in your grandparents' house. None of those cancel the others. They coexist for a while, and the dream accepts that coexistence with eerie calm. That fluidity can feel, at least emotionally, a little like the quantum idea that things are not always pinned down in the clean classical way we imagine. Again, not as a direct scientific equation, but as a resemblance in the style of uncertainty. In the quantum world, a system may be described in terms of possibilities before a measurement yields a definite outcome. In a dream, a scene often feels like possibility lingering before narrative commits itself. A hallway can still become a beach. A friend can still become your brother. A threat can still become a joke. The dream world, like a field of probabilities, often seems willing to remain open a little longer than waking logic would tolerate. And perhaps that is one reason dreams can feel so alive. They have not yet collapsed into a single obvious version of reality. They hover. Not always, and not forever. Dreams do become concrete in their own way, but they often begin with a softness that waking life does not. Objects, identities, relationships, and places can exist in a kind of suspended ambiguity. It is only later, if ever, that they harden into one thing. That is part of what makes dreams feel uncannily rich. They do not always force the mind to choose immediately between alternatives. They let the world remain layered. There is another resemblance too, and it has to do with observation. One of the most peculiar features of dreaming is how often the dream changes when attention changes. You notice something, and in noticing it, the dream shifts. You begin to question a face, and the face becomes another. You look closely at a room, and the room rearranges itself. You realize you are dreaming, and suddenly the entire structure of the dream responds to that realization. The world is no longer the same because your relation to it is no longer the same. That can feel faintly reminiscent of the way quantum theory unsettled the old separation between observer and observed. Not because your sleeping mind is performing laboratory measurements, but because both domains unsettled the fantasy that observation is always passive. In waking common sense, we imagine ourselves as detached spectators of a reality that simply sits there. But in dreams, that separation breaks down. Looking is already participating. Attention is already intervention. The more conscious you become inside a dream, the more the dream often answers back. Lucid dreamers know this especially well. The moment lucidity arrives, the dream does not simply continue unchanged. It becomes different because the dreamer is different inside it. Intentions matter more. Expectations matter more. Fear can destabilize the dream. Calm can lengthen it. Curiosity can open it. Doubt can dissolve it. It is as though the dream world, always constructed from mind, becomes even more responsive once the mind begins to notice itself noticing. And while we should not confuse that with physics, it is still striking. Because both quantum theory and dreaming reveal, in their different ways, that the act of knowing is not always cleanly separated from the structure of what is known. There is also the question of identity. In ordinary waking life, we rely heavily on stable categories. This is my friend. That is my home. I am myself. This happened yesterday. That happened years ago. Such distinctions are the grammar of daily reality. Without them, practical life becomes difficult. Dreams loosen those categories with astonishing ease. One person can contain several people. One place can contain several places. One self can contain several selves. Time can fold. A child version of you can be present without surprise. A dead relative can stand in front of you, not as memory but as current reality. A stranger can feel intimately known. A known person can suddenly feel alien. The borders between identities are not erased, but they are made porous. This too has a faint quantum flavor, again emotionally, not literally. The quantum world resists the comforting notion that everything must belong to one obvious category at all times. Light is not only particle or only wave in the simple everyday sense. Matter behaves in ways that make old labels feel insufficient. At that scale, the universe seems to care less about preserving our conceptual comfort than about being itself. Dreams behave similarly with identity. They are not interested in preserving the neat labels that waking life depends on. They mix, blur, and recombine, and the result is not meaningless. Often it is emotionally exact, even when logically impossible. A dream figure may combine your mother, your partner, and an old teacher into one person, not because the mind is confused in a trivial way, but because those identities have become entangled around some common emotional pattern. Nurture, judgment, longing, safety, guilt. The dream does not care that the waking mind would object. It cares that the emotional relationship is right. This word, entangled, is hard not to use here. Not because dream figures are quantum entangled in the physical sense. That would be far too strong a claim. But because dreaming often reveals how tightly woven our inner world already is. Memories are entangled with emotions. People are entangled with places. Fears are entangled with old scenes. Desires are entangled with shame. Loss is entangled with love. The sleeping mind does not sort these apart into clean files. It lets them rise together. And perhaps that is why dreams can feel so dense, so full of invisible connections. You are never just in one scene in a dream. You are usually standing at the crossing point of several inner histories at once. One of the quietest but most powerful similarities between dreams and quantum weirdness may be this shared refusal to give us a single, classical world too quickly. Both seem to invite a world of relations rather than isolated objects. In waking life, we like to imagine the universe as made of separate things: table, lamp, body, memory, fear, person, event. But at deeper levels, both physics and dreaming suggest that reality may be more woven than separate. In the quantum case, woven through formal relations and non-classical descriptions. In dreams, woven through memory, symbolism, emotional association, and unstable identity. Neither world is made only of solid little boxes. And the human mind, especially the waking mind, finds that hard to accept. There is also the matter of scale. Quantum physics is strange precisely because it governs a level of reality we do not directly experience with our ordinary senses. It is foundational, but hidden. The solid world we know emerges from it, yet does not wear its weirdness openly. Dreaming is similar in a different sense. Dreams emerge from processes we do not consciously control. They are built from mechanisms and meanings below or beyond the narrator of waking life. Their visible surface, the story of the dream, sits on top of deeper structures that remain mostly hidden from the dreamer while dreaming. In both cases, what we experience directly may not be the deepest layer of what is happening. That realization can be humbling. It means the reality we inhabit, whether waking or dreaming, may not be as immediate or transparent as it feels. Beneath the surface there may be architectures we only glimpse indirectly. And yet, even with all these parallels, we have to keep our footing. Because this is exactly the kind of territory where people become too eager. They notice that dreams feel uncertain, and quantum theory involves uncertainty, and suddenly they leap to the claim that dreams are quantum. Or they notice that dreaming responds to observation, and quantum measurement raises deep questions, and suddenly they claim consciousness literally reshapes external reality in the same way. This is where metaphor hardens into mythology, and honest wonder turns into overstatement. We should resist that. A resemblance in feel is not a scientific identity. Dreams do not need to be quantum to be strange. And quantum physics does not need to explain dreams in order to remain astonishing. The better question is gentler. Why do these two domains resonate with one another in the imagination? One answer may be that both expose the limits of classical certainty. Waking common sense depends on clear boundaries, stable objects, single meanings, and linear time. Quantum physics showed that those assumptions fail at fundamental scales. Dreaming shows that those assumptions can also fail inside the mind. In one case, physics unsettles the external world. In the other, sleep unsettles the internal world. The effect is similar. The familiar ground begins to wobble. And when that happens, we feel something very old and very human. We feel that reality is bigger than the frameworks we built to manage it. That feeling can be frightening, but it can also be beautiful. Because dreams and quantum theory, in different ways, both remind us that certainty is not the only possible condition of reality. There are worlds, or modes of worldhood, where ambiguity is not failure but structure. Where multiple associations can coexist. Where identity is relational. Where sequence is not always linear. Where definiteness arrives late, or incompletely, or not in the way we expected. Even our emotional life works that way. A person can grieve and love at once. Fear and longing can inhabit the same room. Relief can carry sadness inside it. Memory can make the absent feel present. Desire can make the future feel already half real. The psyche itself often behaves less like a clean classical system than we pretend. It is layered, superimposed with old and new, certain and uncertain, waking and dreaming all at once. Perhaps that is why quantum metaphors cling so easily to consciousness. Not because they are automatically correct, but because the mind already feels non-classical from the inside. A dream makes that obvious. In a dream, contradictions are not always enemies. They can coexist as atmosphere. You can be afraid of a place and homesick for it in the same breath. A person can be dead and present. You can know and not know at once. You can flee something that is also part of you. The sleeping mind does not always demand resolution. It can inhabit paradox. And quantum theory, at least emotionally, confronts us with something similar. A world in which our old either or categories no longer feel strong enough. There is another aspect of dreaming that deepens this parallel, and it is the sense of provisional reality. When you are in a dream, the world feels real enough to live in, but it is also strangely unstable, as though it could reconfigure at any moment. Behind the scene there is a hidden softness, a sense that things are only temporarily arranged into this particular world. A door may not open into what it did a moment ago. A city may become a forest. A person may become a shadow. The dream feels convincing, but never fully locked. That is part of what makes dreams so haunting. They feel real, but not settled. Quantum descriptions of reality also carry that sense of the provisional. Not in visible dreamlike scenes, of course, but in the way they describe systems through probabilities and possibilities until specific outcomes are obtained. Again, one must be careful. Physics is not dreaming, but both domains introduce us to realities that seem less like hard statues and more like ongoing resolutions. Perhaps this is why dreams can make waking life feel so sharp afterward. When you wake, the room seems almost shockingly definite. The bed is where it should be. The wall does not melt into a street. Your name remains yours. The day has a date. The ordinary world has reasserted itself with classical confidence. And yet the dream lingers as evidence that consciousness can inhabit something much softer without losing its sense of reality while inside it. That fact alone is astonishing. It means the mind is capable of living in uncertainty as though it were a world. And that may be one of the deepest emotional bridges between dreaming and quantum theory. Not proof, not mechanism, but a shared challenge to the assumption that reality must always arrive as something fully resolved. If this quiet exploration is helping you drift, this is a lovely point to like the video, subscribe, or leave a comment about the strangest dream atmosphere you have ever known. Not necessarily the plot, but the feeling of it. Sometimes the feeling says more than the story. Now, it would be unfair to leave this part without saying something even more important. There is a risk in romanticizing uncertainty. Dreams can be beautiful, but they can also be terrifying. Ambiguity can feel profound, but it can also feel destabilizing. The same is true, in a different register, for quantum theory. People are drawn to it because it makes the universe seem mysterious and alive with possibility. But the genuine lesson of quantum physics is not that the world exists to flatter our intuition that anything may be possible. Its lesson is more demanding than that. It says reality may be rigorously lawful while still refusing the simple picture we preferred. Dreams teach something similar. They are not random freedom. They are not pure fantasy without structure. They are shaped by memory, emotion, embodiment, and sleeping brain states. Their uncertainty has form. Their instability has patterns. Their weirdness is not chaos. It is another organization of experience. That may be the most useful way to hold the parallel. Both dreams and quantum weirdness remind us that the world need not be classical to be real. There can be order without ordinary solidity, meaning without strict logic, structure without the kind of neat determinacy that waking common sense finds reassuring. And perhaps that is enough for tonight. Not a grand claim that quantum physics explains dreams. Not a dramatic revelation that dreams prove some hidden theory of the cosmos. Only this quieter insight. Dreams and quantum theory both expose how narrow our instinctive picture of reality really is. One does it in the laboratory. The other does it in the sleeping mind. One shows that matter at its foundation is stranger than expected. The other shows that consciousness can build and inhabit worlds stranger than expected. Together, they suggest that certainty may not be the default condition of existence after all. There may be deeper levels where possibility comes before clarity, where identity is relational, where the observer cannot be cleanly separated from the scene, where time becomes flexible, where reality, before it settles, hovers. And if that is true, then it becomes easier to understand why some people have looked at dreams, looked at quantum theory, and felt that they were standing near neighboring mysteries. Not the same mystery, but neighboring ones, both waiting in the dark, both reminding us that the world, inner and outer, may be less solid than it feels in the bright confidence of day. And that leaves us in the perfect place for the next step. Because once we have let ourselves feel the resonance between dreams and quantum weirdness, another responsibility arrives. We have to step back. We have to ask what mainstream science says about all of this. Where do the parallels stop? What are the strongest objections? Why do so many scientists remain skeptical of quantum consciousness theories, no matter how evocative they may sound? And if the brain really is such a warm, noisy biological system, what would it take for any delicate quantum effect to survive there long enough to matter at all? That is where we go next. Because wonder is valuable. But in science, wonder has to survive criticism if it wants to become truth. Part 9, The Skeptical View. There is a quiet kind of honesty in science that does not always sound dramatic. It does not arrive with thunder. It does not promise final answers. It does not flatter our hunger for mystery by pretending every beautiful idea is true. Sometimes it says something much simpler, and much harder to hear. Maybe not. Maybe this theory is too early. Maybe the evidence is not there yet. Maybe the mind is extraordinary without needing the explanation we find most emotionally satisfying. That is the spirit we need for this part. Because once people hear about quantum consciousness theories, once they hear words like microtubules, superposition, entanglement, and objective reduction, it is very easy to get swept into a certain mood. A mood in which the mystery of consciousness seems finally matched by a theory strange enough to feel worthy of it. A mood in which the brain becomes not just biological, but cosmic. Not just electrical, but quantum in some deep and hidden way. And there is something deeply understandable about that attraction. Consciousness feels unusual. Dreams feel unusual. The quantum world is unusual. So the human mind naturally wonders whether the strangest parts of inner life and the strangest parts of physics might belong together. But science is not only the art of wondering. It is also the art of resisting our favorite conclusions until the world truly earns them. And that is where skepticism enters the story. Not cynicism. Not hostility. Not the kind of shallow dismissal that sneers at any big idea simply because it is ambitious. Real skepticism is calmer than that. More patient. It does not say, "This cannot be true because it sounds strange." It says, "If this is true, what would we need to see? What evidence would make it convincing? What alternative explanations already exist? What assumptions is this theory making? What parts of the idea are poetic, and what parts are actually doing explanatory work?" That kind of skepticism is not the enemy of wonder. It is one of wonder's last protections against self-deception. And when it comes to quantum consciousness theories, there are several major reasons many scientists remain unconvinced. The first reason is also the most famous one. The brain is the wrong kind of place. Or at least, it appears to be. Quantum effects, especially delicate ones like coherent superpositions, are easiest to sustain in systems that are very small, very isolated, and often very cold. That is one reason quantum experiments are so difficult to perform. The phenomena involved can be extraordinarily fragile. The slightest interaction with the surrounding environment can disrupt them. This loss of fragile quantum behavior into ordinary classical outcomes is what physicists usually describe through decoherence. Now think about the brain. The brain is not cold. It is warm. It is not isolated. It is immersed in constant interaction. It is not quiet. It is chemically busy, electrically active, metabolically intense, wet, noisy, and crowded with molecular motion. In other words, The brain looks, at first glance, like a terrible place for delicate quantum coherence to survive long enough to matter in any organized cognitive sense. This is the single most common skeptical objection, and it is not a trivial one. If someone claims that quantum superpositions inside brain structures play a significant role in consciousness, they must explain how such states remain coherent long enough, and in a functionally relevant enough way, to affect neural dynamics. It is not enough to say that the brain is made of atoms and atoms obey quantum laws. Everything is made of atoms. A coffee mug is made of atoms. A brick wall is made of atoms. That fact alone does not mean we need a special quantum explanation for mugs or walls or minds. The question is not whether the brain is physical. The question is whether specifically quantum effects do unique explanatory work for consciousness beyond what classical neural processes already explain. And many scientists remain doubtful because the brain's physical conditions seem so inhospitable to the kinds of quantum states these theories usually require. This criticism has been aimed especially at theories like OR. The theory depends, in part, on the idea that quantum processes inside microtubules could persist long enough and in a sufficiently organized way to matter for conscious events. Skeptics argue that the proposed quantum states would likely decohere far too quickly in such a warm, active biological environment. If the coherence vanishes almost immediately, then it becomes difficult to see how it could meaningfully shape the large-scale activity of the brain in the way the theory hopes. Now, supporters of such theories have responded in different ways. Some suggest that biology may be better at protecting delicate states than earlier critics assumed. Some point to evidence that quantum effects do seem to matter in certain biological systems, like aspects of photosynthesis or possibly animal navigation. And those are serious points worth considering. Biology has surprised us before, but the skeptical answer remains equally serious. Yes, quantum effects may matter in some biological systems, but that does not automatically mean they matter in the specific way required for consciousness. Each claim has to be earned separately. A hint of quantum influence in one living process does not give us permission to smuggle quantum explanations into every mystery we have not solved yet. That distinction matters enormously. Otherwise, quantum stops being a scientific concept and becomes a mood. And that brings us to the second major reason for skepticism. Classical neuroscience already explains a great deal. Not everything, of course. Not the full heart problem, but a great deal. We know that changes to brain chemistry can alter mood, memory, attention, perception, and sense of self. We know that sleep stages correlate with different kinds of experience. We know that damage to specific brain systems can impair language, memory formation, emotional regulation, or conscious responsiveness. We know that anesthesia reliably disrupts consciousness through physical effects on the brain. We know that dreams correlate with particular states of neural activation. We know that wakefulness, focused attention, daydreaming, REM dreaming, deep sleep, coma, delirium, and seizure states all come with different patterns of brain activity. That is not a small achievement. It means that before anyone reaches for a quantum theory, they must first explain why classical neuroscience is insufficient in principle, not merely incomplete in practice. This is a very important difference. Every active science is incomplete in practice. There are always things left to discover. But incomplete does not mean fundamentally incapable. It may simply mean that the work is still underway. Many skeptics argue that quantum consciousness theories jump too quickly from "we do not yet fully understand consciousness" to "therefore the answer may require exotic quantum mechanisms." That leap, they say, is too fast, too eager, too impressed by mystery. After all, there was a time when life itself seemed impossibly mysterious. People wondered whether there must be a special life force beyond chemistry and physics. Over time, biology explained more and more using ordinary physical processes, though never in a way that made life seem any less astonishing. Some scientists suspect the same may happen with consciousness. Not because consciousness is simple, but because complex classical systems may already be capable of far more than our intuitions first expect. In that view, invoking quantum mechanics may be like reaching for fireworks before we have finished exploring the machinery already in front of us. There is a third skeptical concern, and it is subtler. Some theories do not really solve the mystery. They relocate it. This is one of the deepest criticisms of quantum consciousness proposals. Suppose someone says, consciousness arises when some quantum state collapses in a special way. A skeptic may respond, all right, but why should that collapse feel like anything from the inside? You have moved the explanatory burden from neurons firing to quantum reduction, but you have not necessarily explained subjective experience. You have simply changed the vocabulary around the same mystery. This is what I mean by moving the mystery into a smaller room and giving it more exotic furniture. The problem remains. Why should any physical process, whether classical or quantum, produce first-person experience at all? If a theory merely says the relevant process is quantum, but offers no deeper reason why that process becomes experience, then some philosophers would argue it has not solved the hard problem. It has only relocated it to a more glamorous level of description. That criticism is difficult to dismiss, because one of the temptations in consciousness research is to confuse depth of language with depth of explanation. A term like objective reduction can sound profound, and perhaps it is, but the central question remains untouched unless the theory can tell us why such an event should correspond to felt awareness rather than merely being another physical event among many. Skeptics, then, are not only asking whether the biology works. They are also asking whether the explanation actually explains. A fourth concern has to do with testability. Good science needs more than emotional appeal. It needs ways to be challenged by the world. A theory must make claims that can, in principle, be wrong. It must specify mechanisms clearly enough that evidence can bear against them. It must risk failure. Some critics argue that quantum consciousness theories often remain too vague or too difficult to decisively test, especially when discussed in popular form. The public version of these theories can become a cloud of suggestive language without enough clear contact points with experiment. To be fair, this is not true of every serious proposal. Penrose and Hameroff, for example, have tried to articulate mechanisms and engage criticisms. But many derivative versions of quantum consciousness talk, especially outside formal science, are far less disciplined. They use the reputation of physics without the burden of precision, and this can make the whole field seem softer than it should be. A real theory has to do more than say, consciousness is mysterious, quantum physics is mysterious, therefore perhaps they belong together. That is not a theory. That is a mood. Science needs more than that. Another major skeptical point concerns the measurement problem and the old idea that consciousness collapses the wave function. This idea has a long and fascinating history, and it can sound almost irresistible in popular retellings. If quantum systems exist in possibilities until measurement, and if conscious observation seems special, then maybe consciousness turns possibility into reality. It is a powerful story. The problem is that most physicists do not think human consciousness is required in this way. There are many interpretations of quantum mechanics, and they disagree about what exactly measurement means. But in most mainstream scientific practice, measurement is treated as physical interaction yielding definite records, not as a magical event that must wait for a conscious mind to bless it into existence. In other words, the universe was not waiting for humans to arrive before stars could form or atoms could interact. That may sound obvious when stated plainly, but it matters because consciousness collapse talk often survives by sounding more precise than it really is. Skeptics argue that it places human awareness in a privileged role without sufficient necessity. It also tends to encourage the mistaken impression that the human mind literally creates external reality just by observing it, which is far stronger than what the underlying physics supports. And once again, skepticism here is not meanness. It is just an insistence that we not smuggle huge metaphysical claims into small ambiguities. There is also the problem of scale between brain events and conscious unity. Even if some small quantum event occurred somewhere in neural tissue, how would that scale up into the full richness of conscious life? How would it relate to the enormous, distributed activity that we already know accompanies perception, language, memory, emotion, and wakefulness? How would a tiny microphysical event become the living continuity of a person thinking, feeling, dreaming, remembering, hearing music, grieving, or reading words late into the night? A useful theory would need to explain not only the existence of a quantum effect, but the bridge from that effect to large-scale mental organization. Many skeptics feel that bridge remains too weak, too unclear, or too speculative. This is especially important because consciousness does not seem to be a point event. It feels like an organized field. It unfolds across time. It integrates many systems. It is shaped by memory, body state, attention, emotion, and environment. If a theory focuses too narrowly on a tiny event without showing how that event supports the broader architecture of mind, then it risks becoming biologically disconnected from the thing it claims to explain. There is yet another reason skepticism remains strong, and it has more to do with human nature than with equations. People are vulnerable to explanations that preserve mystery while sounding scientific. We do this all the time. We meet a deep or painful or beautiful mystery, and we want an answer that feels equal to it. Not merely accurate, but emotionally resonant. Consciousness seems too luminous to be just biology. Dreams feel too strange to be just sleep. Love feels too large to be just chemistry. So we look for language that lets us keep the mystery alive while still sounding intellectually serious. Quantum language often plays that role, not because it is false, but because it is so easily misused. It can become a kind of shelter for intuitions we do not want to surrender. A way of saying, see, reality is weirder than reductionists admit, and perhaps sometimes that instinct is healthy. Reality is weirder than simple reductionism once assumed. But skepticism reminds us that emotional satisfaction is not the same as empirical support. A theory can feel right and still be wrong. And sometimes the more a theory flatters our longing for depth, the more carefully we should examine it. This is one reason many neuroscientists prefer to stay with explanations that, though less glamorous, remain closer to the evidence. Large-scale network dynamics, integration across cortical regions, predictive processing, recurrent loops, sleep stage physiology, neurochemistry, embodied cognition. These may not sound as mythic as quantum mind theories, but they are tightly tied to observation and experiment. They change when evidence changes. They stay anchored. From the skeptical point of view, this is not narrow-mindedness. It is discipline. And discipline matters most when the mystery is deepest. If this calm walk through the skeptical view is helping you drift deeper, this is a gentle place to like the video, subscribe, or leave a comment about which side of this tension you feel most strongly, the pull toward bold explanations, or the calm patience of skepticism. In a subject like this, both instincts are very human. Now, with all that skepticism laid out, it would be easy to end in a tone of dismissal. But that would miss something important. Because good skepticism does not close the door forever. It only insists that the door remain closed until there is reason to open it. And there are reasons not to become dogmatic on the skeptical side either. Biology has surprised us before. The natural world has repeatedly turned out to be subtler than expected. Processes once thought impossible in living systems have later been demonstrated under the right conditions. So the skeptical position, at its best, is not quantum effects in consciousness are impossible. It is, the current evidence is not strong enough, and the known difficulties are serious. That is a very different sentence. It leaves room for future discovery without pretending present discovery has already occurred. It is also worth remembering that even if quantum consciousness theories fail, the failure would not diminish the mystery of consciousness itself. The hard problem would remain. Dreams would remain strange. The self would remain fluid and partly constructed. Waking experience would remain a world generated inside matter. The brain would remain one of the most astonishing systems we know. In other words, skepticism toward quantum explanations does not force us back into a dull or flattened universe. It only asks us not to reach too quickly for the explanation we most enjoy. Sometimes the bravest thing science can say is not yes, and not no, but not yet. And perhaps that is the sentence hovering over this whole discussion. Not yet. Not enough evidence yet. Not a convincing mechanism yet. Not a clear solution to the hard problem yet. Not a bridge from microphysics to lived experience yet. That does not make the search pointless. It makes it unfinished. And that, too, can be strangely beautiful. Because it means we are still alive inside the question. Still listening. Still trying to understand how matter becomes mind, how sleep becomes dreams, how a brain in darkness becomes a world in light. So let us gather the skeptical view as gently as we can. Skeptics argue that the brain's warm, wet, noisy conditions make delicate quantum coherence hard to sustain in the relevant way. They argue that classical neuroscience already explains a great deal and may yet explain more without needing exotic physics. They argue that many quantum consciousness theories move the mystery rather than solving it. They question whether such theories are sufficiently testable, biologically grounded, or explanatory. They reject the casual idea that human consciousness is obviously required to collapse the wave function. And they warn, wisely, that quantum too easily becomes a placeholder for awe instead of a real mechanism. These are strong objections. Not because they destroy wonder, but because they protect truth from being drowned by it. And once we have passed through that skepticism honestly, the final part of our journey comes into view. Because after all the dreaming, all the quantum uncertainty, all the brain science, all the theories and objections, one question still remains floating quietly above everything else. What, in the end, do dreams and consciousness still leave unanswered? What mysteries remain even after neuroscience, even after physics, even after skepticism has done its careful work? And perhaps most importantly, why does the question of consciousness still feel so open, so luminous, and so difficult to close, even now? That is where we go next. Into the last part. Not to force an ending, but to rest for a while inside the mystery that still remains. Part 10. What dreams and consciousness still leave unanswered. After all the theories, all the brain scans, all the sleep stages, all the careful arguments and elegant objections, we arrive somewhere quieter than certainty. We arrive at the edge. Not the edge of science in the dramatic sense, as if everything beyond this point belongs only to fantasy. And not the edge of reason either, because reason has brought us this far. What I mean is something gentler than that. We have reached the edge of what we can currently explain without pretending the mystery is gone. And perhaps that is the right place to end. Because consciousness has a way of surviving every explanation, not by disproving it, but by remaining slightly larger than the frame around it. You can describe a dream in terms of REM sleep, memory replay, emotional processing, and predictive brain dynamics. All of that is useful. All of it is real. But the dream itself, the felt strangeness of being inside it, still seems to slip just beyond the language of mechanism. You can describe waking awareness in terms of network integration, sensory construction, attention, and neural coordination. Again, all important. All true as far as they go. But still, there remains the silent fact that experience is happening at all. That is the part no equation has fully dissolved. And maybe it never will in the simple, satisfying way we sometimes imagine. We live with a strange hope that mysteries should close cleanly. That if we just gather enough data, use the right model, sharpen the right tools, then one day consciousness will stop feeling mysterious and become as conceptually tidy as the orbit of a planet. But perhaps that expectation says more about our hunger for closure than about the thing itself. Because consciousness is not merely another object in the world. It is the condition through which the world becomes present. It is not something we stand outside of and inspect from a comfortable distance. Even while we study it, we are using it. Even while we theorize about it, we are inside it. Even our doubt about consciousness is conscious doubt. That makes it a uniquely difficult mystery. It is the one thing every explanation depends on while also trying to explain. And dreams deepen that difficulty. Because dreams show us that consciousness does not require the world in the way we often assume. Or rather, it does not require the waking world, the shared world, the stable world. In dreams, consciousness can generate a world from within. Not a perfect world, not a logical one, not a world that obeys daylight standards, but a world all the same. A place with weather, distance, emotion, urgency, memory, and presence. A place where things are encountered, feared, desired, and believed. That alone should unsettle us more than it usually does. Because it means that one of the most intimate features of consciousness is world building. The mind does not merely watch reality. It participates in constructing what reality feels like from the inside. In waking life, it does so under strong external constraints. In dreams, those constraints loosen, and the same constructive powers reveal themselves more openly. The result is not nothingness, but another mode of being. So one of the unanswered questions is this. If consciousness can inhabit both waking and dreaming worlds, what exactly is it that remains constant across those states? Not the scenery. That changes. Not logic. That changes too. Not even the self in its familiar daytime form, because dreams often alter identity, memory, and reflective awareness. And yet something remains. Something is there when a person wakes in the morning and says, "I dreamed." Even if the dream is fragmentary, even if the story is strange, there was still an inner point of view, some mode of presence, some field in which experience took place. What is that? What is the minimum condition for there to be experience rather than none? Science can tell us more and more about the correlates of consciousness, the conditions under which experience appears likely, changes form, or fades. But the deepest character of presence itself, the very fact that there is something it is like to be, still seems curiously untouched. Another unanswered question lies in the relation between consciousness and selfhood. During waking life, the self feels central. I am me. I have a body, a history, a future, a name, a role, a private story that stretches through time. But dreams keep showing us that this stable self may be less fundamental than it appears. In dreams, identity can shift without collapse. You may be yourself, but not quite. You may observe and participate at once. You may accept impossible transitions in identity without alarm. The self can become fluid, and yet experience continues. So perhaps consciousness does not depend as heavily on the narrative self as we imagine. Perhaps the self, at least in the familiar daytime sense, is one arrangement of consciousness rather than its source. A useful arrangement, a powerful one, but not the deepest layer. That possibility changes the emotional tone of the whole mystery. Because many of us spend our lives protecting the waking self as if it were the absolute center of reality. My plans, my memories, my roles, my regrets, my image of who I have been. But dreams keep whispering that the self can loosen, distort, vanish, and reappear, while awareness in some form continues. And if that is true, then perhaps the self is less like a king on a throne and more like a story the mind tells very convincingly under certain conditions. Not a false story exactly, but not the whole truth either. There is also the question of time, which dreams disturb so beautifully. In waking life, time feels like a line. Yesterday behind us, tomorrow ahead, now slipping forward with every breath. We may know intellectually that the physics of time is stranger than that, but the feeling of linear progression is one of the strongest features of being human. And yet dreams keep violating that structure. They collapse years. They bring the dead into the present. They let childhood and adulthood coexist. They create the feeling of long durations inside short intervals. They preserve emotional time rather than clock time. Why does consciousness organize time this way in sleep? What does that tell us about how time is lived, rather than merely measured? It may be that what we call time consciousness is less about clocks than about structure, memory, anticipation, and meaning. The dreaming mind seems perfectly willing to abandon chronological sequence if emotional sequence is preserved. That suggests that the experienced flow of time may be more subjective, more constructed, and more dependent on narrative form than our waking confidence admits. And if that is true in dreams, might it be true, to a lesser degree, in waking life too? How much of the time we think we inhabit is objective duration, and how much is the mind's way of arranging significance? That question remains open too. Then there is the hard problem, the one that keeps returning no matter how many side doors we open. Why should physical processes produce experience at all? We have circled that question many times in this series because it deserves circling. Not because repetition is elegant, but because the question itself refuses to sit still. The brain can be studied as a physical system. Dreams can be correlated with sleep stages. Memory can be modeled. Attention can be tracked. Brain activity can be measured with extraordinary detail. But still, none of that by itself fully explains why there should be any inner life rather than mere function. A machine can process information. A brain also processes information. But somewhere in the brain's processing, experience appears. Color appears. Pain appears. Music appears. Longing appears. A dream appears. And we still do not know why. Some people hear that and feel disappointed with science. But I do not think disappointment is the right response. The fact that science has not yet solved consciousness does not mean it has failed. It means the mystery is real enough to resist easy victory. In a way, that should make us trust the problem more, not less. It means we are dealing with something that cannot be flattened by cleverness alone. And perhaps that is why so many people become tempted by bold theories. Quantum consciousness, spiritual accounts, philosophical idealism, panpsychism, higher-order theories, integrated information, predictive processing, global workspaces, and all the rest. Each of them feels, in its own way, like an attempt to reach the center of the maze. Some may be more promising than others. Some may survive. Some may fade. But their very existence reveals something important. No one who has really sat with consciousness finds it easy to dismiss. That includes skeptics. Even the most disciplined skeptic of quantum mind theories usually agrees on one thing. Consciousness is still deeply unresolved. Dreams are still deeply strange. The brain is still one of the most astonishing things in the universe. The disagreement is not over whether the mystery is real. It is over how carefully we should move through it. And careful movement matters. Because unanswered questions are fertile, but they are also dangerous. They invite humility, but they also invite projection. Into every unresolved mystery, people are tempted to pour whatever they most want to be true. Some want consciousness to be fully explainable through ordinary biology, because that feels intellectually clean. Others want it to reach deeper into the fabric of the cosmos, because that feels emotionally truer to the experience of being alive. Both impulses are understandable. Neither should be allowed to outrun the evidence. The honest position remains difficult. We know a lot. We do not know enough. And we must learn to live in that sentence without trying to decorate it into certainty. Perhaps one of the most beautiful unanswered questions is about why dreams so often feel meaningful even when they are irrational. You have probably had a dream like this. Not necessarily dramatic. Sometimes the most haunting dreams are quiet. You walk through an old house. You speak to someone you have lost. You stand in a room full of light that seems to belong to no real place. You wake with the sense that something happened, even if you cannot explain what. Not because the dream delivered a literal message, but because it carried a truth in atmosphere rather than in statement. Science can say much about this. Emotional memory, associative recombination, limbic activation, reduced frontal oversight, all valid. And yet those terms do not fully cancel the felt significance. Why should the mind be able to create experiences that feel charged with meaning even when their logic is broken? Why does symbolism arise so naturally in sleep? Why does the dreaming brain not merely replay but transform? Maybe because meaning itself is not as rational as we pretend. Maybe meaning is always partly atmospheric, partly embodied, partly relational, partly symbolic. Maybe waking life only hides that under stronger rules. In dreams, those deeper layers have more room to show themselves. And if that is true, then dreams are not just side effects. They may be one of the purest places where the mind reveals how it lives inside meaning before explanation catches up. There is another unanswered question that hovers quietly beneath everything else. Why does consciousness feel unified? At any given moment, countless processes are unfolding in the brain and body. Vision, memory, internal sensation, language, mood, thought, body position, anticipation, and subconscious regulation all occur together. Yet our experience usually arrives as one experience, one world, one now, one field of presence. How? This question has scientific versions, philosophical versions, and almost spiritual versions, but none of them fully close it. Somehow the pieces do not remain as pieces. They become a lived whole. In dreams, that whole can loosen or warp, but even then it usually remains a whole of some sort. A strange whole, perhaps, but still one world at a time. What is the basis of that unity? What binds sensation, memory, and feeling into something that can be lived rather than merely processed? We have models. Good ones, sometimes brilliant ones. But the wholeness itself still feels a step ahead of us. And then, beyond all of that, there is the oldest unanswered question of all. What is the relationship between consciousness and reality? Not just the brain, but reality itself. Does consciousness emerge entirely from matter arranged in the right way? Is it a late product of complexity? Is it somehow woven more deeply into the structure of nature? Does the universe become conscious only in brains like ours, or is mind-like interiority present in some faint form more broadly than we realize? Is consciousness a localized event, or is our current framework too narrow even to ask the question well? We do not know. That sentence may frustrate some people, but I think it should also calm us. Because the need to know immediately is often what makes thinking sloppy. A mystery does not become smaller because we rush. It becomes distorted. And some mysteries may need to be lived with for a while before they can be properly seen. There is a particular kind of peace in that. Not the peace of answer, but the peace of honest scale. The realization that the universe is old, the brain is strange, dreams are deep, and human understanding is still growing. We are not failing because we have not solved consciousness yet. We are simply still inside the work of trying. If this gentle series has been helping you unwind, this would be a lovely point to like the video, subscribe, or leave a comment about which question stays with you most after all of this: the mystery of dreams, the nature of self, the hard problem of consciousness, or the possibility that reality is stranger than waking life usually lets us feel. Quiet questions have a way of traveling far. Now, if I had to gather everything we have explored and place it into one calm picture, it might sound like this. Dreams show us that the mind can create worlds. Sleep shows us that consciousness changes shape rather than simply switching on and off. Memory shows us that the past lives inside us as reconstruction, not merely storage. The brain shows us that matter can become organized enough to generate extraordinary patterns of life and experience. Quantum physics shows us that the foundations of reality are subtler and less classical than common sense once imagined. Skepticism shows us that mystery should be respected enough not to be solved too quickly. And through all of it, consciousness remains. Present in waking, present in dreaming, present in questioning, present even in our inability to fully explain the presence itself. That may be the final wonder. Not that consciousness is mysterious in spite of science, but that science, at its best, has revealed just how deep the mystery really is. Not by turning everything into fog, but by sharpening the outlines of what remains unresolved. And perhaps that is why this topic has such a strange emotional pull. It is not only about brains or dreams or physics. It is about the most intimate fact of existence, that the universe is not merely there, but here, for someone, from somewhere, in the form of a lived world. You, me, any creature who dreams, suffers, feels, waits, remembers, listens in the dark. The mystery of consciousness is the mystery of how there can be an inside to existence at all. And there is something almost tender in realizing that even now, after all our theories, after all our technology, after all our arguments, that tenderness remains unexplained. Maybe that is not a failure. Maybe it is part of what keeps the world alive. A final thought, then, before we let the night take the rest. Perhaps consciousness is not a puzzle waiting to be snapped shut so much as a horizon that keeps moving as we approach it. Every discovery brings us closer and also reveals more landscape beyond. The brain becomes clearer, and the question deepens. Dreams become more understandable, and their strangeness becomes more intimate. Physics becomes more precise, and reality becomes less intuitively familiar. The result is not defeat. It is depth. So if you find yourself lying awake sometimes, wondering what a dream really is, or why the self feels stable by day and porous by night, or how a few pounds of living tissue can hold grief, memory, love, and the image of an impossible sky, then you are not standing outside science. You are standing exactly where science begins. In wonder, in uncertainty, in the refusal to stop asking. And perhaps that is the most human thing of all. We dream, and then we wake. We explain, and still the mystery glows. We build theories, and still there is music in the unanswered. We live inside consciousness every moment of our lives, and yet it remains, somehow, like moonlight on water, visible, undeniable, and never fully caught. So as this journey comes to rest, do not worry if it ends without a final answer. Some subjects are not poorer for that. Some become more beautiful. And tonight, perhaps that is enough. The brain is real. Dreams are real. The laws of physics are real. Your experience is real. And whatever consciousness finally turns out to be, whether it arises entirely from matter, or whether matter itself is stranger than we have yet learned how to say, the mystery remains one of the most extraordinary things we have ever been able to notice. Not because it belongs only to philosophers or physicists, but because it belongs to anyone who has ever closed their eyes, entered a dream, and then awakened with the strange and gentle feeling that the world, both inner and outer, is deeper than daylight usually allows. And if you carry that feeling with you into sleep tonight, then maybe the unanswered questions have already done something valuable. Maybe they have not solved the mystery. Maybe they have simply made reality feel larger, softer, and more alive. And sometimes, for a mind preparing to rest, that is more than enough.